Fred Hoyle's universe. Three scientists named Fred Hoyle could enter the history of science at once. One was one of those immortals whose names are reverently listed, barely mentioned Einstein, but it was not yet the turn of the others. The second one was adored by journalists. He was always ready to throw them a couple of ideas that they would argue about for years. These are the ideas and hypotheses that, even if they do not always feed science, but certainly spur it, make it develop. Finally, the third is, to tell the truth, a failed scientist who, in his heart, probably has long considered himself a journalist, a writer. He's full of witty paradoxes. And he must have sprayed all his talent on it. Three scientists, three destinies. One person. Englishman Fred Hoyle, years of life 1915-1984, was a very different person, ambiguous. It was as if he had lived 3 lives, or maybe more, in the allotted number of years. He is called one of the greatest astronomers of the 20th century. His ideas were brilliant. He truly revolutionized science. He is considered one of the strangest scientists of the 20th century. His ideas were often absurd, erroneous. And maybe, by and large, he was not even a man, but a machine for the production of ideas. The printer standing on the next table does not care what it will print. Sometimes it seemed that Hoyle didn't care what he said to his colleagues, as long as the idea was unusual. So, he was a diligent creator of scientific theories and scientific myths. If we turn to his first hypothesis, it will suffice to say that in 1957, Hoyle published a classic work on the thermonuclear synthesis of chemical elements in the nuclei of stars. It was co-authored by astronomers Margaret and Geoffrey Burbage and physicist William Fowler. Before that, no one could explain where the whole world around us came from, because the phrase "the world was born in the flame of the Big Bang" is just a beautiful crackling phrase. During the Big Bang, only 2 chemical elements appeared, hydrogen and helium, and not our entire world. No one could understand by what alchemical miracle helium turned into potassium, nickel, boron, and so on. And carbon and oxygen separated from hydrogen. It's good that it's not hydrogen. As brilliant as this achievement was, so was his failure in another field of astronomy. In the 1920s, several scientists, Einstein, Friedmann, Lemaitre, Hubble, came up with the same idea in different ways. We live in a universe that is rapidly expanding. Obviously, it was once the size of a certain first atom. Hoyle thought it was nonsense. In 1949, speaking on the BBC radio station, Hoyle parroted this picture of the birth of the universe, contemptuously calling it Big Bang. The senselessness of these sounds, it seemed to him, emphasized the absurdity of what was happening. But it turned out that he did not come up with a swear word, but a new brand. The theory that angered him has even more fans. Hoyle himself defended another theory, the steady-state universe, the theory of the stationary universe, which he had developed a year earlier with Hermann Bondi and Thomas Gold. In this theory, the universe expanded, but expanded forever. She had no beginning. So elegantly the question disappeared, and what was before the Big Bang? But then a new question appeared. If my desk suddenly began to expand, would soon not find a notebook or a fountain pen at hand. They have gone far ahead. In other words, if the universe is expanding forever, then its space should be mostly empty. Hoyle did not hesitate to suggest that matter is constantly being spontaneously generated in the void at such a rate that the average density of the universe always remains the same. New stars and galaxies are gradually forming from this substance, filling the gaps between the old ones that are flying away, Russian astronomer Serdin wrote on the pages of the journal Knowledge Power. At the time of its appearance, Fred Hoyle's theory claimed to be the foundation of cosmology. Indeed, it was difficult to refute it. Most scientists abandoned it only after the cosmic background radiation predicted by the Big Bang theory was discovered in 1965. It became the standard model of cosmology. Another favorite topic of the scientific heretic Hoyle is another damned question of science: the origin of life on Earth. After all, if we live in an eternal universe, then life, along with space and time, can be an integral property of the universe. In the 1970s, with the development of cosmonautics, interest in the hypothesis of panspermia, the transfer of life from one celestial body to another, was reawakened. Hoyle, along with his student Chandra Vikramasinghe, who was born in 1939, will publish more than one article defending the same unusual view for many. The universe is teeming with life. These works brought Hoyle, Sir Den writes in an essay on the worlds of Freddie Hoyle, scandalous popularity. The idea of panspermia was rejected by both astrophysicists and biologists. Theologians clung to it. But Hoyle and Vikramasinghe calmly developed their views. Here's what they thought: myriads of bacterial spores are scurrying around in space. Some lurked in the cores of comets, Noah's arks of evolution. Others crammed into the rustle on meteorites. Still others crossed the cosmic ocean without any vehicles, float on it, unprotected by anything but dust. They swim and survive. When the spores get into a fertile environment, they multiply rapidly, turning the desert into a blooming garden. This is how the history of life on Earth began. Hoyle and Vikramasinghe justified their hypothesis with the results of spectral analysis of cosmic dust. Its infrared spectra are very similar to the spectra of organic matter, in particular, dry bacteria. Subsequently, observing the radiation of distant galaxies, Vikramasinghe came to the conclusion that microbial spores can even fly from one galaxy to another. According to Vikramasinghe, there are 10 to the 33rd degree tons of microbial spores in the Milky Way alone. Truly, moving from one planet to another, from one star to another, a squadron of astronomical dimensions cruises in space, dropping troops on every piece of the firmament lurking on the way. Sealed in spore capsules, these primitive organisms, unlike the crown of human creation, can travel through the stellar worlds for millions of years. Along with comets, pathogenic microbes and viruses can also penetrate from space. According to Hoyle, the plague, HIV infection, mad cow disease were brought to Earth from there. Here science is invisible to readers, replaced by pure fiction. The ideas and hypotheses expressed by Hoyle can no longer be tested experimentally, given the possibilities available to us. One can only believe in them or perceive them as science fiction. Hoyle wrote it too. On the pages of the novel Black Cloud, he drew an unthinkable picture. He described a seemingly ordinary gas dust cloud stretched out in space. However, it turns into a huge living being under his pen. Thinking clouds could communicate with each other, reason and summarize by sending directional radio signals in the direction of their fellows. Maybe we already live surrounded by these intelligent alien creatures that seem to us only a dead part of the surrounding world. Endowed with extraordinary creative power, Fred Hoyle was a genius in his insights. And what if those guesses of his that seem to us today a scientific myth, the day after tomorrow will become a new word in science? The myth of aliens they have settled since ancient times in the dreams of poets and utopias of thinkers, in philosophical novels and fantastic stories, in myths and fairy tales. They sometimes save people, then frighten, then, like gods, reveal the greatest secrets to us, then, possessed by satanic passion, they try to destroy us. Over the past millennia, the collective brain of humanity seems to have thought through all imaginable scenarios of the Great Contact. Meetings with aliens, our brothers in mind or enemies in mind, natural competitors in the struggle for a place under the starry sky. The great philosopher Immanuel Kant, who spoke with awe and admiration about the starry sky above and the moral law inside us, was convinced that the neighboring planets of the solar system are also inhabited by intelligent beings. And that the farther the planets are located from the Sun, the more intelligent their inhabitants are. The Belgian biochemist Christian de Duff, winner of the Nobel Prize in Medicine in 1974, considered life a cosmic inevitability. Another Nobel laureate of 1965, molecular biologist Jacques Monod, on the contrary, held the opinion that man is the only intelligent being who accidentally arose among the indifferent immensity of the universe. The opinions of astronomers also differ. Some say that space is teeming with life. Their opponents put so many conditions limiting its origin and development that in their models the Earth is lost among a lifeless desert in which we and our descendants cannot get through to anyone. Disputes about extraterrestrial life are so fruitless, scientific discussions are so contradictory that getting acquainted with different views on this scientific problem, finding yourself literally at the crossroads of opinions, you feel in a hopeless impasse. The problem is so speculative that you understand with particular acuteness how the disputants lack a solid ground of facts under their feet. In this abyss of our ignorance, it is so easy to give up hope, to accept the abyss. After all, at the beginning of the space age, since our spacecraft went into outer space, we have not found any extraterrestrial organisms, or alien artifacts, or even a trace of vanished life. The only thing we managed to find after all the unsuccessful searches and disputes is an action plan for the coming decades, or even centuries. Here is the direction of the main blows, which, perhaps, will allow us to overtake extraterrestrial life, catch it by surprise, scare, or even convince highly developed civilizations, if there are any, to turn their attention to us. The radius of the first impact is limited by the size of the solar system, and now we already understand that only a catch of microscopically small sizes can wait here. After all, on Mars, as well as the moons of Jupiter and Saturn, science in principle allows the existence of microorganisms in the present or distant past. The area of the second impact is exoplanets. It would seem that not so long ago, a couple of decades ago, the world sensation was the news that the first planet outside the solar system was discovered in the constellation of Pegasus. Since then, the count of distant planets has long gone to thousands, and no one is surprised that news regularly comes that a new planet discovered by astronomers is close in size to Earth. A new generation of telescopes will allow us in the coming decades to perform quite routine spectral analysis of the atmosphere of exoplanets located within a radius of a couple dozen light-years from Earth. Knowing the composition of the atmosphere, it is possible to judge whether such planets can be inhabited. But only the third blow can bring the desired success. And is it possible to reasonably estimate the probability of the existence of advanced civilizations in the Milky Way and other galaxies? Let's take a look at the recent settlement records of some scientists. American astronomers Peter Beruzzi and Molly Peebles have shown that most of the planets were formed a very long time ago. 80% of the Earth-like planets and 50% of the gas giant planets are at least 4.6 billion years old, that is, they are older than the solar system. There may be up to 1 billion Earth-like planets and up to 10 billion gas giants in our galaxy alone. Based on this condition, Beruzzi and Peebles suggested that there are many thousands of civilizations in the vast expanses of the Milky Way. Adam Frank from the University of Rochester in New York and Woodruff Sullivan from the University of Washington in Seattle estimated the number of stars in the universe we observe. It was almost 10 to the 23rd degree. If we consider that there are about a dozen planets orbiting near a star named the Sun, then the probability that we are alone in the universe is about 1 to 10 to the 24th power. There is no direct answer to the question of whether we are alone in the universe, but the very unnaturalness of this figure suggests a negative answer. If you get out of your native galaxy, then even inveterate skeptics are ready to find extraterrestrial civilizations there. So, a few years ago, American scientists astronomer Michael Hart and physicist Frank Tipler suggested that our civilization is the only one in the Milky Way. But in this case, they could not disagree with the fact that in any other of the vast array of galaxies, there is also at least one habitable planet, and maybe there has developed its own technological civilization. However, the space separating our star islands is so large that all extraterrestrial civilizations are forever isolated from each other. But still, can we detect real signs of the existence of aliens today? For a long time, with the advent of radio, scientists have been thinking that if there is intelligent life outside the Earth, it can give itself away with radio signals. In 1960, the American astronomer Francis Drake, using the 26-meter radio telescope of the National Radio Astronomy Observatory, began to monitor signals that could come from two stars, Tau Ceti and Epsilon Redan. Since then, our telescopes have been observing various parts of the sky more than once, trying to intercept signals from extraterrestrial civilizations. However, it was all in vain. This does not mean that there are no such signals and cannot be. This means that the task is much more difficult than it seemed to us at first. We don't know where to expect a signal from. The universe is immensely large. The spectrum of frequencies at which radio interception should be conducted is also very large. In addition, there are many natural radio sources in space. They confuse scientists. Finally, no one knows if we are looking for something. Do aliens use radio waves to exchange information? Or have they developed a fundamentally different connection long ago? Meanwhile, we are entering a new level of search. In the 2015 year, the Break Truff program was launched at the expense of Russian billionaire Yuri Milner. By the 2025 year, its participants should study the surroundings of 1 million stars, including several thousand stars located near the Sun. Scientists are interested in any traces of some artificial processes, that is, the technical activities of the inhabitants of the star worlds. Astronomers now have two of the largest telescopes in the northern and southern hemispheres at their disposal. The Robert Byrd Radio Telescope in Greenbank with a parabolic mirror over 100 meters in diameter and the Parkes Radio Telescope in southeastern Australia. Its diameter is 64 meters. Have aliens ever been to the solar system? The topics of table conversations are unacceptable: family, work, cars, sports, favorite hobby. However, in the summer of 1950th year, when two famous physicists, Nobel laureate Enrico Fermi years of life 1901–1954 and the father of the hydrogen bomb Edward Teller, met at the same table in the dining room of the Los Alamos laboratory, their chatter could seem to the neighbors some abstruse fantasy. They talked, no less, about interstellar travel. About this unique opportunity to rush from star to star, as from one end of America to the other. At that time, UFO machines of alien visitors really began to be noticed in different parts of the USA. They were deceived, but their appearance, like any phenomenon, could be explained theoretically. Suddenly Fermi interrupted his colleague's reasoning with the question, "Where are they all?" This was the first time Fermi's paradox sounded. Calculations have shown that if some extraterrestrial civilization reached the level at which it is possible to build spaceships, it would take only a few million years to fly around our entire galaxy. To visit wherever possible. Fermi solved this problem, much to the delight of pessimists and skeptics. If no traces of extraterrestrial life have been found so far, then it simply does not exist. Otherwise, the galaxy would have been settled long ago, and our solar system would have been given over to space colonists, would have become a raw appendage of the great civilization of the Milky Way. In the late 1980s, the British astrophysicist Martin Fock suggested that our galaxy was completely mastered by aliens even before the emergence of the solar system. According to his idea, if at least one of the civilizations lost here learns to make interstellar flights, then the methodical colonization of space will begin. If we follow this logic, then all the planetary systems in the vicinity of the solar system have long been inhabited by aliens. And our cosmic abode itself, even during it, could not but arouse their interest. Their cosmonauts have been here, observing individual planets, especially the planets of the terrestrial group. And maybe even now there are the means of tracking the local fauna left by them. Follow us with you. They know about us. But where are they all? It's time to exclaim after Fermi. They are. And where are the traces of millions of people who lived on Earth in the distant past? Traces of Trojans and Hats, Olmecs and Phoenicians, Neanderthals and Cro-Magnons rest in the ground. The idea of searching on Earth for artifacts left by aliens who allegedly visited here in ancient times is far from new. Erich von Däniken and his main followers have long managed to compromise it with their immoderate discoveries. In the spring of the 2017 year, interest in the rejected, ridiculed idea was reawakened in scientific circles. Astrophysicist from the University of Pennsylvania Jason Wright published an article on the popular scientific website Archive, which was devoted to this controversial idea. So, what if there was some kind of advanced civilization in the solar system in the distant past? Or, let's say, messengers of distant civilizations have been here. Is it possible, after perhaps many hundreds of millions of years, to find traces of its existence? If so, where to find them? Where extraterrestrial artifacts could rest. In the film 2000 and the First Space Odyssey, in a mythological documentary, as director Stanley Kubrick called his film, the distant ancestors of man suddenly discover a mysterious monolith, a faceted obelisk made of black stone. Millions of years later, astronauts find the same monolith on the moon. Of course, for this fantasy alone, which suddenly found ground under your feet, you can be awarded the most severe criticism. Therefore, it must be emphasized that Wright does not at all believe that there was once a certain vanished civilization in our solar system. He only asks questions: where in the solar system is it most likely to find traces of some vanished civilization? And where they shouldn't be looked for. Wright's idea does not seem scientific, but we have no facts proving that in the distant past our planet was not visited by aliens. As there are no traces of their appearance here. This idea can be dismissed as an empty fantasy, but it is impossible to prove with arguments that it is nonsense. If, after leaving the Earth, we mentally transfer ourselves to other planets, then with our trained gaze, the gaze of the space age, we can easily identify a number of celestial bodies where aliens could once settle in. So where? On Venus, which in the distant past was not much different from our planet in terms of living conditions. That's just from 500 to 800 million years ago, Venus experienced a series of grandiose volcanic eruptions. Powerful lava flows then hid all traces of the existence of life. It would be much more interesting to look for traces of an alien presence on Mars. The surface of the red planet is not split into dozens of lithospheric plates hurrying to be melted down. If an alien settlement was once built there, then turning into ruins, it will hide under a thick layer of dust, but it will not disappear. On the contrary, the ruins will be safely preserved. Of course, our artificial vehicles have been on Mars more than once, and they didn't find anything like our fantasies. Maybe this is due to the fact that we tried to find traces of life on Mars, but today's life. Special equipment was not used to search for artifacts deep in the Martian soil. Traces of alien space expeditions could be searched even on the neighboring moon. And even more so by the forerunners of the solar system, on asteroids forming the Kuiper belt. According to Wright, on these minor planets, perhaps one day there will be ancient mines and quarries left clearly not by man. Or maybe asteroids were used as space beacons, warning signs of danger that reminded passing starships that it was risky to turn here, to the sun. So, perhaps billions of years ago, on some planets of the solar system, and it may be that on Earth, aliens visited, obsessed with the same curiosity as our researchers, who, as if an unknown instinct prompts them to conquer the moon, colonize Mars, settled on several planets at once. In a word, to soar up above the Earth. The same unknown instinct probably sends anxiety to the insect pupa before it turns into a butterfly. Perhaps there were not only separate robotic bases of aliens in the vastness of the solar system, but also a whole network of their settlements on different planets and satellites, which was subsequently abandoned by them or perished. Assessing our activity in conquering the surrounding outer space, we cannot but understand that any other civilization that originated hundreds of millions or billions of years ago within the boundaries of the solar system or penetrated into it would also behave. However, during this time, the appearance of, for example, the Earth has changed so much that the presence of aliens here in the distant past can be suspected only by the strange ratio of some isotopes. So maybe amazing finds are waiting for space archaeologists on the Moon, Mars, asteroids or satellites of giant planets. The planet is a volcano. In the 19th century, astronomers discovered that the true orbit of Mercury differs from that ideal ellipse, which should be according to Kepler's law. After making a revolution, Mercury does not return to its starting point. In other words, its perigelium, that is, the point of the orbit closest to the Sun, shifts slightly with each new revolution. How can this be explained? On the 2nd of January, 1860, Urbain Le Verrier, one of the discoverers of the planet Neptune, giving a lecture in Paris, proposed a rather convincing hypothesis. Either there is a planet smaller than Mercury between the Sun and Mercury, or there is another asteroid belt, similar to the one that separates the orbits of Jupiter and Mars. Due to the proximity to the Sun, these celestial bodies are inaccessible for observation. You can see them only during a solar eclipse or at the moments of their passage through the solar disk. A few months before his lecture, Leverett received a letter from the amateur astronomer Edmond Lecarbo. He reported that on the 26th of March, 1859, he discovered a round black spot that passed through the disk of the Sun and looked like a planet. Lescarbault observed this spot for 75 minutes. During this time, it crossed almost a quarter of the solar disk. The correspondent also indicated the inclination of the orbit of the proposed planet. Using this information, Le Verrier calculated the period of rotation of this planet, 19 days and 7 hours, and its distance to the Sun. It was 7 times closer to him than the Earth. Its diameter and mass were significantly smaller than the same parameters of Mercury. Such a planet was too small to explain the errors in the motion of Mercury. And wasn't it just the largest object in that scattering of asteroids that probably encircles Le Verrier literally fell in love with the mysterious planet? He called it a volcano. Another Le Verrier correspondent, Professor Rutherford from Zurich, also discovered strange spots on the Sun. Calculations have shown that if these are planets, then they move in 2 characteristic orbits. The circulation period of one is 26 days, and the second is 38 days. The problem is that it is very difficult to observe objects inside the orbit of Mercury, since this part of the firmament is brightly illuminated by the Sun's rays. During such observations, the optics of the telescope can be damaged. They are also dangerous for astronomers' eyesight. In addition, due to glare caused by bright light, researchers may accidentally see some specks near the Sun, that is, objects that are not there. For more than half a century, astronomers have been trying to discover a hypothetical volcano planet. In 1860, a solar eclipse took place in Spain. The event when the disk of the sun should have faded, the planet or planets surrounding it should come out from behind a curtain of dazzling radiance. Leverrier called on all French astronomers, as well as several foreign colleagues to observe the volcano planet. However, it could not be detected. But it was not a complete defeat, the collapse of a dream. Leverrier was sure to the end of his days that the volcano planet exists. And shortly before the death of the famous French scientist, a new proof of this was made public. On the 4th of April, 1875, the German astronomer Weber noticed a round spot on the Sun. Calculations showed that on the eve of the Sun's disk, both the planet whose orbit was previously calculated by Leverrier and the planet with a period of 38 days, which Rudolf Wolff allegedly discovered, had to pass through. Did they all come together to turn out to be a volcano planet? And the difference in one day is a calculation error? Meanwhile, on the 29th of July, 1878, a solar eclipse took place again. James Watson, a professor of astronomy at the University of Michigan, noticed two glowing dots at once. Apparently, two small planets located between Mercury and the Sun. Another American astronomer, Lewis Swift, one of the discoverers of the Swift-Tuttle comet, who returned to us in 1992, saw only one star, a volcano planet, but it was away from the objects discovered by Watson. Needless to say, this time the location of all three planets did not coincide with Leverrier's instructions. So, there was no volcano, but suddenly there were four planets at once. Solar eclipses kept repeating, but the volcano planet stubbornly eluded observation. After many years of unsuccessful searches, most astronomers began to doubt that this ghost planet exists. When, in 1916, Einstein published the general theory of relativity, it became obvious that the features of Mercury's motion could be perfectly explained with the help of this theory. Instead of cluttering up the Sun's surroundings with planets. According to it, the Sun bends space and distorts the orbits of the planets. If we describe the motion of Mercury in Euclidean space according to the laws of Newton's mechanics, it seems that it is moving too fast. However, if we turn to it in Clyde geometry in Einstein's theory, the oddities disappear. The difference in calculations is the same 43 angular seconds that once prompted Leverrier to come up with a volcano planet. Now it had to be written off as unnecessary. In May, 1929, wanting to bring final clarity to the protracted dispute, the German astronomer Erwin Freundlich arrived in Sumatra to observe a total solar eclipse. Later, he carefully examined all the photographic plates, revealed on them a lot of stars that lit up on the black firmament in the daytime. But there was no volcano planet there. The last surge of interest in this planet was observed almost half a century ago, in 1970. When several astronomers reported at once that they had seen unknown objects located near the Sun during a total solar eclipse. For example, the American astronomer Henry Corton was sure that he had managed to prove the existence of the planet Vulcan. According to his calculations, it rotates around the Sun for 11 days, being at a distance of 0.96 thousand astronomical units from it. She herself is very small, its diameter ranges from 300 to 800 kilometers. But the discovery was not confirmed this time either. For many decades, astronomers have repeatedly observed this planet. What did they actually see? The same Leskerbot hardly fantasized when reporting his discovery. He stated it quite reliably, and such an authoritative astronomer as Leverrier believed him. Perhaps, say modern researchers, Leskerbot accidentally noticed an asteroid flying near the Earth. Nowadays, similar asteroids are discovered almost every year, but then they were unknown. Seeing this mysterious object against the background of the Sun, Leskerbot decided that this planet is located even closer to the Sun than Mercury. It is possible that other researchers have also seen the asteroid pass through the Sun's disk, although no such case has been recorded to date. Such experienced astronomers as Swift and Watson, obsessed with the desire to find a volcano planet, could mistake for it the stars that appeared in the sky at the time of the solar eclipse. In the case of Watson, this is proven. He ranked the stars Theta and Zeta from the constellation Cancer among the planets. Corton probably mistook a comet that happened to be near the Sun for a volcano planet. Subsequently, astronomers have repeatedly observed comets approaching the Sun. Finally, some errors could be caused by a defect in the optics. For this reason, another amateur astronomer could mistake some speck for an unknown planet. Where are the Martian canals? Popular rumor has long dedicated the planet Mars to the god of war. Her red face seemed to be warmed with blood. At the end of the 19th century, bloody Mars suddenly became the planet of life. In 1877, the Italian astronomer Giovanni Schiaparelli, who was distinguished by unusual visual acuity, noticed strange thin lines on Mars. He called them channels, which in Italian means channels. They connected dark spots the Martian seas, or stretched to the polar caps. Schiaparelli believed that channels are depressions of natural origin, perhaps giant riverbeds that connect different reservoirs with each other. Soon there were guesses that these channels are artificial structures. They were dug by the inhabitants of the planet, the Martians. The channels began in the polar regions of Mars. Obviously, during the hot summer months, when the ice was melting, the water rushed through the channels to the southern arid areas and irrigated the fields sown by industrious Martians. Only one thing was confusing: if people were able to see the channels, it means that their width reaches several hundred kilometers, otherwise they would not have been noticed. Who came up with the idea of digging such wide channels? The answer to this question was offered by the American Percival Lovell, who founded an observatory in Arizona in 1894, specifically for observing the Martian channels. According to him, floodplains overgrown with dense vegetation were drawn in around the canal. They stood out sharply against the background of the neighboring desert areas. Lovell built an observatory to observe our brethren remaking the nature of Mars at will. Gradually, he compiled an extensive map of the Martian canals. He counted about 700 of them. They formed a geometrically correct network on the map. Unlike the rivers of Earth, winding like snakes, they were drawn like a ruler. Now it was hard not to believe that intelligent beings had built them. At the turn of the 19th and 20th centuries, few people, except astronomers themselves, and even then not all, doubted that Mars was inhabited. The human world of Mars is probably much ahead of us in everything and has achieved great perfection, wrote French astronomer Camille Flammarion. The Martians built cities and learned all kinds of arts. They believed in the Martians as fervently as they believe in UFOs these days. Articles in popular newspapers and magazines were dedicated to them. Their lives became the subject of books by famous writers and a popular plot of popular literature. In 1898, H. G. Wells wrote The War of the Worlds, a chronicle of battles with alien Martians. In turn, the heroes of Alexei Tolstoy's novel Elite, written in 1922 and 23 years, went to Mars with Bolshevik enthusiasm. Later there will be the Martian Chronicles of Ray Bradbury in 1950, The Way of the Martians by Isaac Asimov in 1955. We owe our fantasies about Martians to the canonical image of an alien. A little green man with antennae on his head, this is how the character of a comic book appeared to the public, which appeared in 1913 year and, of course, dedicated to the adventures of a resident of Mars. Most often, science fiction writers were in a hurry to assure the reading public that Mars is inhabited by insidious, evil creatures who only think about how to attack timid, gullible Earthlings and seize their home and abode. In memory, albeit in the form of a curiosity, the mass panic that engulfed thousands of Americans in 1938 is still alive. There was a regular radio broadcast. Suddenly, the announcer reported that a giant cylindrical object had just crashed in the state of New Jersey. The next news was more disturbing. A huge creature emerged from the wreckage of the cylinder, moving many of its tentacles. Other monsters were already tossing and turning behind him. They started attacking people. Everyone was seized with fright. The confused townsfolk took the magnificent staging for a genuine report about the invasion of the Martian colonial army into the limits of terrestrial space. Invincible enemies, measuring the height of skyscrapers, mercilessly spewed fire, mowing down the unfortunate Yankees like grass. In horror and despair, people fled from their radios and, jumping into cars, raced wherever they looked. Some even tried to commit suicide, just not to wait for the arrival of the invaders. American director Orson Welles, the author of that scandalous production, did not expect such a success, which turned into a psychosis, not a triumph. It is amazing that this enthusiasm and these fears were largely generated only by an optical illusion. The human brain is used to replacing rows of dots or dashes with solid lines. Nowadays, people are sometimes ready to take any atmospheric phenomenon for a UFO. At the beginning of the last century, any dots, specks, stripes seen on Mars unwittingly twisted into a slender network of channels. At all times, fans of the most outlandish hypotheses were ready to replace the facts with their beliefs and fanatical faith in them. Stanislav Lem says, and yet, when you look at these magnificent Schiaparelli maps, it just doesn't fit in your head that he saw something that doesn't exist. And that the strangest others after him saw it too. It was some kind of psychological phenomenon. Subsequently, no one was interested in him anymore. But still, a considerable part of the channels sketched from Schiaparelli and other astronomers were not a figment of their imagination. These are genuine relief details discovered later on Mars. Grand canyons, valleys, terraces, depressions or chains of craters stretching into the distance. For example, such a canyon as the Mariner Valley stretches for almost 4,500 kilometers. Its width in places reaches up to 700 kilometers, and the depth varies from 2 to 7 kilometers. Schiaparelli and his followers undoubtedly managed to make out this canyon. Already in the 1930s, the conviction is growing that there are no channels on Mars. They seem to be an observer. At the beginning of the next decade, American astronomer Fred Whipple wrote in his book Earth, Moon and Planets, "We are unable to detect signs of intelligent life on Mars." The reader can form his own opinion. If he believes that intelligent beings could once have evolved on Mars, then he can only imagine that they continued to exist for countless generations in a rarefied atmosphere, almost devoid of oxygen and water, on a planet where the nights are much colder than our Arctic winters. The presence of intelligent life on Mars is not impossible, but it has not been proven at all. However, only after the American probe Mariner 4 in 1965 sent photos of Mars, all speculation on the topic of life there stopped. For the first time in the history of mankind, we saw photographs of another planet taken from a close distance. 22 of them were taken in these pictures. The surface of Mars looked more like the Moon than the Earth. This was a bitter disappointment for everyone who, after the discovery of the Martian canals at the end of the 19th century, believed that there could be some kind of life on this planet. On Mars there were no irrigators, no reclamation workers, nor the grandiose fruits of their labor. There were no channels. At first, Mars was even going to be deleted from the number of objects that should be studied with the help of space probes. But for more than half a century, his research has been successfully continuing, including with the use of rovers. And increasingly, politicians and businessmen are saying that the first manned flight to Mars will take place this century. Sunspots to the crisis. Extraneous factors undoubtedly affect the economy. However, scientists have rarely agreed to allow the entire world economy to obey, as if by an inexorable law, the influence of some natural phenomenon. But this is exactly the case with the theory of the British economist William Stanley Jevons, years of life 1835–1882, who is considered the founder of the mathematical school in political economy. For several years, the scientist, known for his rigor in his work, was engaged in a seemingly unsuitable task for a professor. He monitored solar activity and compared it with what the conjuncture was in the economy. The result of this hobby were several works, including the article Commercial Crises and Sunspots, published in the magazine Nature in 1878. Jevons tried to explain in them how events taking place on the sun set the entire economic machine in motion, causing it to shake in a crisis. Each time, his arguments turned out to be unconvincing. He never deduced his mathematically verified law. Jevons was one of the most versatile economists of his time. The author of the famous books The Theory of Political Economy 1871 and The Principles of Science. A Treatise on Logic and Scientific Method of 1874. But his fascination with sunspots was often laughed at, it seemed so frivolous and unscientific. But let's try to understand the logic of Jevons. He proceeded from the fact that the economy is a balanced system based on the mechanics of profit and self-interest. There are small deviations from the equilibrium, but they are immediately smoothed out. Large fluctuations and especially crises in such a system are impossible. Just as a pendulum swinging steadily cannot begin to rotate around its axis. However, the pendulum of the economy is moving against the rules with frightening frequency. Economic crises occur regularly. So, reality refutes the theory. What if the reason for this is not related to the economy? From the mid-1870s, Jevons, who was interested in meteorology in his youth, drew attention to such a factor as the weather. With enviable persistence, he tried to understand what could connect capricious, changeable weather and, theoretically, a stable economy. Suddenly it occurred to him that meteorology, like economics, also has its own fluctuations. They can be compared with fluctuations in the market. However, in order to explain how the crisis comes, how the celestial machinery destroys the well-established mechanism of earthly life, the economist Jevons had to turn into a storyteller. Carefully and skillfully weave a chain of imaginary events that, with logical inevitability, will lead to an increase in prices and stock market panic. Here is one path that opens up in the maze of events. But is it possible to call it the only correct, natural? Spots regularly appear in the sun. The sun is getting darker, the light is getting weaker, the weather is getting worse, there are no roads or crops in the fields, grain prices are rising, the stock exchange is looking to the future with despondency and anxiety, the affairs of many people are becoming more deplorable. Both economic crises and solar activity are recurring events. One thing comes after another. Following the darkening of the sun, economic life also darkens. A crisis is coming. It would seem that everything is logical, but is it inevitable? Jevons turns to historical facts, and here a blow awaits him. In the 1740th year, England, judging by what solar activity was before that, had to go through a severe crisis. However, this did not happen. Why? Perhaps due to the fact that the center of world trade was then not England, but Holland. Jevons even sends a letter to a friend of the economist Vissering with a request to help with archival research and establish whether there was a crisis then. The answer was discouraging. I didn't find any traces. Maybe some kind of crisis happened then, but it was completely forgotten. However, the failure did not prompt Jevons to abandon the original hypothesis. Solar activity is to blame for any economic crises. It generates a chain of events that culminates in stock market crashes, rapid price increases, mass bankruptcies, unemployment and hunger. In this case, if the scheme is considered correct a priori, the error lies in the fact that the wrong indicator of the crisis is selected. Indeed, every time a crisis begins with some event that sets a gloomy mood and portends worse times. Every time it's a special event. Once the crisis began with the fact that wool prices began to rise rapidly. Another time, insurance companies began to multiply. For the third time, all the newspapers suddenly began to write about the imminent crisis, and it came. Finally, Jevons made his choice: grain prices. If they grow fast, you have to prepare for the worst. At the same time, Jevons chose grain prices in the country where the demand for it is especially high, in India. There, the price increase, even a small one, is very sensitive for the population. In addition, India is a backward country living on agriculture, and it always suffers from bad weather. In addition, the crisis in India, a British colony, inevitably affects the entire European economy. For Jevons himself, his hypothesis was important because here the main cause of economic crises, spots on the sun, regularly reminded of itself. The spots were growing, and it was necessary to prepare for the worst. The implacability of a fundamental physical law was felt here. Knowing the cause of the sunspots in such an amount, it seemed that one could safely predict the consequences. The crisis would begin then. Contemporaries considered Jevons' theory a professorial quirk. Today, economists take it much more seriously. For example, the American economic historian Philip Mirowski believes that, developing the theory of sunspots, Jevons, perhaps for the last time, tried to save the neoclassical model of the market. It seemed perfect, and any crisis in it could be justified by the accidental influence of extraneous factors. Jevons' mistake was that he tried to explain the very existence of economic cycles by a single reason. Moreover, it is exogenous, that is, outside the economic cause. Jevons himself, Arnold Toynbee noted in his book Studies of History, later agreed that periodic economic falls are mental in nature, depending on changes in discouragement, optimism, excitement, frustration and panic. Still, it must be admitted that Jevons was partly right. We all live in the power of the luminary reigning over us. We are insanely animated when the echoes of distant storms reach us, then we seem to fall into hibernation, throw sneakers and pants, as soon as the sun calms down, whose energy feeds humanity and whose energy is so often lacking for the success of decisive actions. Not only people, but also all living things on our planet, and she herself reacts violently to the processes taking place on the sun. Apparently, in the era of the highest tension of solar activity, the number of reasons that have epidemics to strengthen and develop increases, wrote the Russian scientist Chizevsky. The statistical data collected by him are finding new confirmations. And before him, many, like, for example, Jevons, investigated the dependence of terrestrial processes on the state of the sun, but only Chizevsky presented heliobiology as an independent branch of knowledge. He brilliantly proved that fluctuations in the activity of the sun cause the behavior of the masses by their influence, thereby influencing the distribution over time of the very phenomena that make up the social life of human communities. Not everything depends on the social. But a lot. The inner space of the Earth. In the autumn of 1869, an American named Cyrus Titus, the years of his life 1839-1908, conducted an alchemical experiment trying to turn lead into gold. But due to an oversight, he received a strong electric shock that knocked him off his feet. That's where enlightenment came. While he was lying in oblivion, he dreamed of an extraordinary picture of the world, which contradicted what generations of stargazers and astronomers claimed. The Earth was indeed shaped like a ball. But she was a hollow ball. People did not live on the outer surface, but inside a sphere filled with the sky and celestial bodies. Why did none of the scientists from Galileo to Herschel notice this? Because they all came from a false premise. From the fact that light travels in a straight line. If this is not the case, and the light rays are bent, then it seems to the observer that the cosmos that has opened up to him is infinite. The knowledge revealed to the half-dead Teed destroyed this illusion. It remained to speculate the rest. The thickness of the Earth's firmament under our feet, Titus now announced, is only 100 miles, that is, 160 kilometers. The diameter of the sphere in which we are enclosed, like a chick in an egg, reaches only 8,000 miles, 12,875 kilometers. 3 more transparent spherical shells are placed inside the globe. The layer of the atmosphere adjacent directly to the inner surface of the Earth, followed by a shell of hydrogen and, finally, in the middle of the shell and collecting. But how then to explain the riddle of the sun? After all, it shone brightly in the sky, disturbing the harmony of the spheres. In his book Cellular Cosmogony or the Earth as a Hollow Ball, published in 1898, Cyrus Tipp wrote, "The sun is an invisible electromagnetic energy source that is located in the center of a hollow ball and rotates around its axis. The sun we see is only a reflection, just like the moon. The sun is located only a few thousand kilometers from the concave surface of the Earth. The size of the luminary is small. As for the planets and stars adorning the firmament, they do not exist. They are just numerous reflections of sunlight. The sun itself is two-faced, like the legendary Janus. It has a light and dark side, and, making a complete revolution around its axis, within 24 hours it turns to us now with a light, then with a dark side. Day and night come in turn." A similar Titus explained the alternation of the seasons, shocking astronomers. Physicists were outraged to learn that only those light rays that are directed directly to the center of the hollow world move in a straight line. All other rays move under the arc of circles. The closer the light rays pass to the center of the hollow world, the slower they spread. In its central part, any movement slows down. The speed of light is thus not constant. However, for an observer inside the system, this is not noticeable. As for gravity, it is generated by the sun. These are special rays emitted by it, in addition to light. They are then reflected from the metal layers present in the ground. As in the geocentric system, the Earth occupies a special position in this system of the world. Only if in Ptolemy's teaching and in medieval systems of cosmology it occupied a central place in the universe, then Cyrus Theed's spherical Earth forms the boundary of the world we see. Here, however, the question cannot but arise, what is on the outer side of the Earth? Maybe the Earth continues indefinitely after all. But Titus the long-suffering finally woke up. Now he had only one goal in life. He decided to convey to people the revelation he received, the apocalypse of Cyrus. Overnight, he turned from a doctor into the founder of a new faith, a modern prophet. He adopted a new name, or rather took the Hebrew version of his name, Koresh. He created a new society, the Korshansky Union. In 1870, the first meeting of supporters of the new creed was held in New York. Then he went to Chicago, San Francisco. There was no large influx of the public, but nevertheless his sermons and lectures gathered enthusiasts who rejected, like him, modern scientific views, because the earth turned into a grain of sand lost in the boundless cosmos. An unexpected meeting prompted him to take new actions. During one of his missionary trips to Chicago, he met the inventor, publisher and surveyor Ulysses Grant Morrow. Years of life 1864–1950. They liked each other from the first conversation. No one will explain to Professor Morrow now why he carried this title, joined the Christian Union, having decided, as a scientist should, to set up an outstanding scientific experiment and unequivocally prove the correctness of Cyrus Theed. Morrow designed a gigantic ruler, with the help of which it was possible to mechanically set the horizontal at any point of the globe. This device, literally a straightener, was needed by Morrow to measure the curvature of the Earth's surface. This value, he believed, could tell for sure whether we live on the surface of a convex ball open to the boundless cosmos, or are imprisoned inside a hollow ball and doomed to peer into the void closed above our heads, colored by imaginary reflections of a single light. The straightener consisted of 4 segments with a length of 3 whole 64/100ths of a meter each. Crossbars were attached to both ends at right angles. With their help, it was possible to dock segments with each other. The position of any segment was adjusted to the nearest millimeter. The total length of the entire structure, which was attached to 2 racks, was 14 whole. Disassembled the rear part of the structure, removed the racks and rearranged them to a new place. The professor had only to reconfigure the assembled unit. By the beginning of May, 1897, the structure had been rearranged from place to place 1,045 times. During this time, she covered a distance of 3 kilometers 800 meters and reached the sea. And what did the experimenters themselves achieve with these measurements? What they wanted. Cyrus Theed's rightness was confirmed, the professor and the preacher declared in one voice. The sea level rises towards the horizon because we live inside a huge concave sphere. However, the scientific revolution did not take place. In scientific circles, they did not believe 2 strange people from the scientific world, who secretly, without witnesses and opponents, measured something there and now shook tables with numbers. It was impossible to deny the psychological interest of all participants in the experiment. They all wanted to confirm the correctness of their teacher. And in a strange way, everything was brilliantly confirmed. Here you will inevitably think about the fact that this whole experience was staged as one big performance, not to make a discovery, but to demonstrate the results needed by sectarians. It remains to add that the idea of a concave cosmos has not died to this day. Let her vegetate on the desolate expanses of the internet, where her few adherents enthusiastically discuss how our world really works. The doctrine of eternal ice. On a summer morning in 1925, all famous German and Austrian scientists received letters of the same content. A storm of indignation swept through laboratories and libraries. After all, the text was an ultimatum. It's time to choose who you want to be with us or against us. While Hitler clears politics, Hans Erbiger sweeps away false sciences. The doctrine of eternal ice will become a symbol of the renewal of the German people. Be aware of this. Join us, otherwise it will be too late. The man who dared to threaten scientists was called that way, Hans Herbiger, or in another transcription, Herbiger. He turned 65 that year. His long gray beard made him look like an angry prophet. He had a reason to get into a ruckus and rage. He undertook to preach to people the truth, which they rejected, because it absolutely contradicted all the basic principles of astronomy and mathematics. Herbiger, like a madman, decided to discard the 1,000-year history of science and start everything from scratch, on which only one of his names will be inscribed. Objective science is a pernicious invention, a totem of decadence. Like Hitler, he believed that the most urgent task was to know who wanted to know. Only a prophet like him has the right to engage in science, because the power of his enlightenment elevates him to the highest level of consciousness. At the same time, by science, he meant not at all what everyone used to understand by this. The revelations of science were not sent to him alone. He did not know the slightest doubt. Any weakest objection infuriated him. "You trust mathematical equations, not me," he thundered. "How long does it take you to finally understand that mathematics is an insignificant lie?" What truth was revealed to him? What is the doctrine of eternal ice? The Austrian engineer Hans Herbiger, years of life 1861,931, promulgated his doctrine on the eve of the Great War, in 1913. It was bright and crazy, like the speech of a madman. According to this doctrine, millions of years ago in the constellation Blue there was a giant star whose mass was millions of times greater than the mass of the Sun. Once a huge planet, consisting of water ice with a metal core in the middle, crashed into it. During the collision, the icy surface of the planet was covered with a powerful crust of slag, and therefore it did not melt immediately, but remained inside the star for a long time. Eventually, all the water ice evaporated. A huge amount of water vapor accumulated inside the star, and it exploded like an overheated steam boiler. Fragments of the star scattered across the universe. The explosion scattered its lightest elements the furthest. They formed a sparkling Milky Way. From the remaining parts, from the frozen water vapor, the solar system emerged, as well as the icy Milky Way, which now lies in its vicinity. Only 3 times farther from the Sun than the planet Neptune. The entire solar system is dotted with countless ice floes and clouds of hydrogen, which Herbiger called ether. They interfere with the movement of the planets, gradually slowing them down. Over time, the small planets began to move so slowly that they finally joined the large planets and became their satellites. Someday all of them will collapse on the surface of these planets. In turn, the planets will sooner or later approach the Sun and evaporate. There are already few of them left. Initially there were more than 30 of them. The ring surrounding Saturn is a remnant of intra-Uranus. The outer planets, Mars, Jupiter, Saturn, Uranus and Neptune Herbiger called them neptodes, are pure water balls covered with a thick layer of ice. The inner planets, or heliota, are Venus and Mercury, composed mainly of metals. A crust of thin ice covers them. This thin ice is formed in interplanetary ice blocks formed during the primary explosion fall on the Sun. Their fall leads to the appearance of spots on the Sun, and the water pores evaporate and, having flown into outer space, freeze. On Earth, we observe this thin ice in the form of cirrus clouds. In the solar system, the Earth occupies a median position. It is not covered by a crust of thin ice, like Venus, by non-kilometer layers of ice, like the Moon or Mars. The Moon itself was once a planet, and now it is approaching the Earth and will inevitably break under the weight of its weight. Its fragments will fall to the ground, destroying everything in its path. There have already been several similar catastrophes in the history of our planet. The last time the icy fragments of the sixth moon, which collapsed to Earth, melted, the biblical flood began. About 12,000 years ago, when the Earth captured the current moon, there was also a flood. Then Atlantis perished. The memory of these global catastrophes has been preserved by Germanic myths, telling, in particular, about the twilight of the gods, as well as the revelations of John the theologian Apocalypse. According to Herbiger, one day, when he was looking at the moon through a telescope for several hours in a row, he had an epiphany. In 1 second, he realized that the radiance emanating from the moon was caused by the fact that it was all covered with ice. This discovery, he expected, would bring him immortal fame. A few nights later, he had a second epiphany. In a dream, he saw the universe. He saw a silvery pendulum that swung uncontrollably, grew larger and suddenly disintegrated. At the same time, he realized that Newton had made a mistake, and the force of attraction of the Sun no longer acts at a distance 3 times greater than the distance from the Sun to Neptune. Based on these insights, he created the doctrine of eternal ice. The whole universe is an arena of incessant struggle between fire and ice. Between Neptunism and Plutonism. The solar system was born as a result of the cosmic collision of the flaming mother of the Sun and the ice giant. In 1913 Herbigger published his Revelations. It was a weighty, almost 800 pages, hard-to-read volume called The Glacial Cosmogony, on which he had been working since 1894. From the very beginning, he believed that his teaching was infallible, stating, as Otsov, "It is only true that she agrees with me, and that she does not agree is wrong." However, his folio was at first almost unnoticed by anyone, but after the war, a form of hysteria unfolded around Herbigger. The Society of Eternal Ice arose. Herbigger Institute in Vienna. Adherents of the new doctrine demanded to cancel routine astronomy lessons, chanting "We want Herbigger." There were fans even among intellectuals. For example, this catastrophic teaching fascinated the poet Gottfried Benn. Scientists unanimously rejected his revelations, so much the worse for them. After all, he is the only German genius. What do these professors say? Do the photos show that the Milky Way consists of billions of stars? All these pictures are fabricated by reactionary astronomers. Does his picture of the world contradict any calculations made according to the rules of celestial mechanics? These calculations only lead away from the true path. He told one of his opponents bluntly, "Either you will learn to believe me, or you will become my personal enemy." Herbigger did not live to see the Third Reich. But his teachings inspired the Nazis, who called him the Copernicus of the 20th century. His admirers were Hitler, Himmler and other criminal leaders of the country. The Ahnenerbe Society, founded in 1933 to study everything related to the spirit of the Nordic race, and integrated into the SS in 1937, did not ignore this doctrine either. After all, a war was approaching between the Solar Third Reich and the Ice Kingdom, the USSR. The collapse of the Reich was also the collapse of the doctrine of eternal ice. After 1945, only lovers of esotericism were interested in her. A star against a star named the Sun. For many centuries, people have been convinced that the planets were created by God. It was only in the 18th century that the first scientific theories appeared explaining the distant past of the solar system. The modern theory of its origin is based on the hypothesis of the 18th-century German philosopher Immanuel Kant, years of life 1724–1804, who was the first to suggest that a vast nebula of gas and dust rotated in place of the solar system. Gradually, it condensed and divided into the central cluster of the Sun and the rings surrounding it, from which the planets were formed. However, Kant's main astronomical work, The Universal Natural History and Theory of the Sky of 1755, in which this idea was expressed, did not arouse any interest among modern scientists. Only almost 100 years later, the French astronomer François Arago rediscovered Kant's hypothesis. Several decades have passed, and the French mathematician and astronomer Pierre-Simon Laplace, years of life 1749–1827, independently came to the same idea. In the year 1796, in the last of the 5 volumes of the Exposition of the System of the World, where all the astronomical information known at that time was collected, he suggested that the solar system originated from a hot gas nebula surrounding the Sun. Now this theory is called the Kant-Laplace theory. In the 19th century, it was a generally accepted cosmogonic theory. However, in the second half of the century, the British physicist James Maxwell of the year of life 1831–1879 revealed its shortcomings. According to his calculations, it turned out that differential rotation should have prevented the condensation of matter on the periphery of the future solar system. In addition, it was impossible to explain why 98% of the moment of the solar system's motion is accounted for by planets moving in their orbits, although their total mass is 750 times less than the mass of the Sun. In the end, the British physicist and astronomer James Hopwood Jeans' years of life 1877, 1946, trying to explain why the amount of movement of the Sun is so negligible, proposed his own hypothesis of the origin of the solar system, which for 2 decades was popular with astronomers. Powerful tidal forces that emerged during the accidental convergence of 2 stars prevented a collision. But at what cost? Huge amounts of matter were torn out of both luminaries. When this swirling substance eventually calmed down, and the alien star, the troublemaker of the heavenly world, disappeared in the distance, planets formed from this substance, now surrounding the Sun with their motley family. However, a detailed analysis of Jeans' hypothesis showed its inconsistency. She was rejected. In modern cosmogony, catastrophic hypotheses are not considered at all. Already in the 1940s, astronomers returned to the theory of Kant and Laplace, slightly modifying it. The initial mass of the protoplanets was clarified, and the deficit in the amount of motion could be explained by the actions of magnetic forces. Today, this is the generally accepted theory of the origin of the solar system. It can be added that according to current ideas, the gas-dust nebula that gave birth to our and many other planetary systems consisted mainly of hydrogen and helium, which were formed during the Big Bang. Less than 1% accounted for impurities in the form of dust particles containing heavier elements and compounds. For example, water, ammonia, carbon monoxide, carbon dioxide. The individual parts of this nebula were shrinking and compacting. The reason for this could be the explosions of supernovae in the immediate vicinity of it. The shock waves generated by these explosions penetrated the nebula, causing the appearance of clumps in it. They became the embryos of presumably several hundred or even thousands of stars, a star cluster that, after hundreds of millions of years, broke up into many single and double stars. One of these stars was the Sun, surrounded by its gas-dust cloud. Millions of years passed until planets appeared near the Sun. The protoplanetary disk from which they originated stretched for many billions of kilometers. Its mass could be from 1 to 10% of the mass of the star. According to astronomers, the formation of the solar system was completed about 4 as many as 568 thousandths of a billion years ago. The calculation error is 2 million years. Scientists came to this conclusion by studying meteorites of a certain type, whose composition is close to the composition of the protoplanetary disk. Astronomers estimate that the formation of the solar system was completed about 4,568,000,000 years ago. The calculation error is 2 million years. Scientists came to this conclusion by examining meteorites of a certain type, whose composition is close to the composition of the protoplanetary disk. The decisive influence on the formation of planets was their distance from the Sun. First of all, refractory substances and compounds condensed in its vicinity, while the solar wind carried volatile substances to the periphery of the solar system, where gas giants were born. Currently, stone balls are located near the Sun, Earth-type planets. From the remaining matter that was not captured by the planets, small celestial bodies were formed, comets and asteroids. They have hardly changed since the formation of the solar system. Therefore, their research can clarify many, still unclear aspects of this theory. The search for trans-Pluto and the abundance of the Kuiper belt. In 1846, the planet Neptune was discovered at the tip of the pen. It was located on the other side of the orbit of Uranus. Its apparent trajectory did not coincide with the calculated one. These deviations could only be caused by the attraction of Planet X, as one of the enthusiasts of its search, the American astronomer Percival Lovell, dubbed it. Years of life 1855, 1916. From 1905 until his death, he methodically searched for this object. Realizing that a distant planet must have a low brightness, Lovell ordered a special photographic telescope, an astrograph. But this long-term work did not lead to the desired result. However, the staff of his laboratory did not stop searching for an unknown planet. 14 years after the death of the romantic astronomer on February 18, 1930, his young colleague Clyde William Tombaugh, years of life 1906, 1997, discovered the ninth planet. It looked like a star of the 15th magnitude in the constellation Gemini. For several months before that, he photographed some part of the sky every night through a telescope, and then, a few nights later, repeated the shooting. During the day, he scanned hundreds of stars on the photographic plates he received, trying to find a point that had shifted among them, to find a new planet. The reason for such a protracted search was not only the small size of the planet, but also the accuracy of predictions. The new celestial body was found 500 million kilometers closer to the Sun than Lovell believed, and its orbit was strongly inclined to the orbits of other planets. A little later, the name of the long-awaited newcomer was coined. The Greek god of the underworld, Pluto, began to rule the planet, where eternal twilight reigns. But there was something wrong in Pluto's domain, too. The remote regions of the solar system still harbored a lot of mystery. As it soon turned out, Pluto was too small to cause the observed deviations in the motion of Neptune. So maybe there, on the other side of Pluto's orbit, there were other planets similar to it. Or at least 1/10th planet. At that time, the manner of discovering objects on the tip of a pen was popular among astronomers. They calculated the possible mass of the trans-Pluto of this unknown planet, which could cause the oddities of the circulation of Neptune and Uranus, although it was not possible to prove its existence. Obviously, it very rarely approaches other planets, because its orbit is unusually elongated. It makes a complete revolution in 800 years. Now it has distanced itself from the rest of the planets and does not affect their behavior in any way. It's too hard to notice her. She is lost among countless stars, and it will take a very long time to find her. Astrologers, more inclined to wishful thinking, even came up with a name for it, Proserpine. So the Romans called the goddess of the underworld. Clyde Tombaugh, fully confident that the solar system does not end with Pluto, continued to search for the 10th planet for 13 years after his discovery. Over the years, he has checked 45 million suspicious objects, but they all turned out to be stars. It seems that the orbit of Pluto should be considered the boundary of the solar system. But his other colleagues didn't think so. Since 1957 year, the American astronomer Henry Lee Jickla's years of life 1910-2007 led a systematic photographing of areas of the sky where trans-Pluto could be located. This work lasted 18 years. Only in the 1980s, after the flight of the Voyager 2 space probe, the mass of the distant giant planets was clarified. As it turned out, because of this, previous calculations suffered from errors. When new values of their masses were substituted into the equations describing the orbits of Uranus and Neptune, all deviations disappeared. Now it became clear that only comets and asteroids could be on the other side of Pluto. Scientists have already managed to replenish the solar system with new planets with the stroke of a pen. Now the pen had to be used to cross out possible planets. However, the observation of remote areas of the solar system continued. Moreover, Pluto itself remained a completely mysterious planet, about which we knew almost as much as about distant stars. It soon became clear that myriads of minor planets were circling on the other side of Neptune's orbit. The first of them, in addition to Pluto and its satellite Charon, 1992 QB1, was discovered in August 1992. Its diameter was estimated at 200 kilometers. It moved in an almost circular orbit at a distance of 50 astronomical units from the Sun. In March and September of 1993, several more asteroids were found on the outskirts of the Solar System. In the following years, the discoveries were put on stream. Pluto turned out to be only the brightest representative of an extensive family of small planets forming the second asteroid belt in the Solar System, the Kuiper Belt. Today, 1,500 objects are already known to be included in this cluster, a flat ring of enormous width. It begins just beyond the orbit of Neptune, 30 astronomical units from the Sun, and ends perhaps at a distance of 100 to 150 astronomical units from the Sun. It is assumed that this belt is also the source of comets with short and medium orbital periods. When, in the 2005 year, it was announced that it was possible to discover Eris, a planet the size of Pluto, its diameter is only 50 to 60 kilometers smaller than Pluto, astronomers were alarmed that the number of planets in the Solar System would soon increase significantly, and they separated the wheat from the chaff. Pluto and others like it have been crossed out from among the main planets of the Solar System. The last 8 are left. And even if the mysterious ninth planet, which astronomers are looking for again, is still found, they will come up with some special status for it. They will be considered, for example, large peripheral objects of the Solar System, POSS. In principle, astronomers do not exclude that an unknown planet may exist on the periphery of the Solar System. A ghost planet, a quiet planet. It does not disrupt the movement of asteroids known to us in any way. It went unnoticed by both telescopes and those few probes that flew to the outskirts of our cosmic world. It certainly moves in a very elongated orbit at a great distance from the Sun. The plane of its orbit is strongly inclined to the plane of the ecliptic. But it is unlikely that there, in the impenetrable darkness of the outskirts, a brown dwarf or an invisible satellite of the Sun, the dwarf star Nemesis, is hiding. In all likelihood, they would have been spotted by our telescopes. Perhaps this planet X should be called not a trans-Pluto, but a transcoder. After all, calculations show that it should be outside the Kuiper Belt. In the 2016 year, American astronomers Konstantin Batygin and Michael Brown reported from the pages of the Astronomical Journal that the mass of this unknown planet should exceed the mass of the Earth by at least 10 times, and the period of revolution around the Sun could be 20,000 years. It is located 600 times farther from the Sun than the Earth. Astronomical scales are already beginning there. The light will pass this distance in about 3.5 days. But the history of this planet is a completely different story. Scientists have yet to figure out whether this is a myth or a fact. Astronomy. The age-old power of astrology. The main objections to astrology, the most popular of pseudosciences, are well known and convincing. Statistics confidently speak against it. Judging by the results of numerous studies conducted in different countries, the position of the Sun in the zodiac at the time of birth does not affect the formation of personality. Here is just one example out of many cited in his works by the Russian astronomer Serdin. French statistician Michel Dequelin studied archival data containing the date, time and deposit of 41,000 inhabitants of Europe. Among them were 16,000 famous scientists, artists, writers, athletes and so on, and also 25,000 ordinary people. Haeckelin compared the position of the planets and constellations at the time of a person's birth with his personality type and occupation. He concluded that there is no connection between the character and activity of a person, on the one hand, his zodiac sign, the position of the planets in the houses and their mutual aspects at the time of birth, on the other. However, until the 20th century, the most important task of astrology was not the compilation of horoscopes for ordinary people, about the predictions of future events by the banner, not sent from heaven. The stars and planets scattered across the firmament are also usually their own, like cards dropped from a fortune teller or dice noisily thrown on the table. Astrologers advised kings and generals when it was better to declare war, march or make peace. To do this, in anticipation of a happy confluence of planets, they were observing the starry sky. Astrology was born in the distant past, when a stroke of fate, the wrath of the almighty gods could fall on people from everywhere, and one could only guess when and where it would happen. If the gods in almost all religions and cultures descended to man from heaven, then maybe, before revealing their decision, they lit the heavenly lights. In this case, the future could not but be read in the light of the stars and the brilliance of the planets. It is known that the roots of modern Western astrology go back to the pre-Christian era, Babylon, Mesopotamia, ancient Egypt. And, probably, they stretch even further, to where no one's writings have preserved the memory of this. In that hoary antiquity, next to astrology, this honorable one accident, a celestial phenomenon, with another, with an earthly event, their arbitrary coincidences became law. From a scientific point of view, astrology, as it was in the ancient world, is not a superstition, but a protoscience, that is, a teaching, a science that has not yet become, noted American researcher Lawrence Geron in his book Astrology in Modern Sciences, Critical Analysis. The search for patterns in the world around us and their description is a scientific approach. It is not for nothing that the famous German philosopher Ernst Cassirer noted almost 100 years ago that scientific forms of thinking are fundamentally used in astrology. The reasons are analyzed, conclusions are drawn, inevitably following the initial conditions, and, finally, the final results are summed up. Astrology was based on the opinion generally accepted in ancient times that celestial bodies directly affect earthly events. To assess this influence, astrologers used mathematical methods to identify patterns in celestial phenomena. Since the most important role in the predictions was played by the time of the event, astrologers made detailed tables through long-term observations. They indicated the position of the most important celestial bodies at certain points in time. Using the methods of geometry, they built the orbits of the planets. This was how the foundations of the future science of astronomy were laid. The history of astrology in Europe was changeable. The ancient Greeks borrowed the zodiac signs and the horoscope system from the Babylonians. In the 3rd and 2nd centuries BC, the treatise The Emerald Tablet appeared, attributed to Hermes Trismegistus. There, in particular, it was said, "What is below is like what is above, and vice versa. What is above is like what is below." The triumph of Christianity in the Roman Empire led at first to the prohibition of astrology. This decision was made by the Laodicean Council in the 364th year. It is not fitting for the illuminated or acolytes to be magicians or charmers, or number givers, or astrologers. The Church persecuted astrologers, as well as sorcerers, healers, mimes. They all undermined faith in God. However, astrology survived these persecutions. She was helped by her duality, proximity to astronomy, the science of stars and planets. In the 8th century, learned astronomy flourished in the Byzantine Empire. In the late Middle Ages, under the guise of astronomy, it penetrates into schools. Already in the 12th century, common schools appeared in Europe, accessible not only for monks. They taught 7 liberal arts, which were divided into trivium and quadrium. The trivium consisted of grammar, rhetoric, and dialectics, while the quadrium consisted of arithmetic, astronomy, music, and geometry. Moreover, geometry was actually geography, and astronomy was astrology. During the Renaissance, astrology was popular throughout Europe. No wonder in Schiller's famous drama The Death of Wallenstein, dedicated to the events of the 30 Years' War from 1618 to 1648 year. Its main character, the commander Albrecht Wallenstein, in the very first scene gazes with greedy joy at a large black board on which the position of the planets is inscribed to astrologers. It promises him an unprecedented triumph. A happy confluence of planets. The Great Triad is fatal. The pernicious insidious Mars fell between 2 luminaries that are so favorable to me, Venus and Jupiter. They will subdue a malicious enemy to us. However, already from the title of the play it is clear how cruelly the stars will laugh. Instead of triumph, Wallenstein was honored with death. The spirit of the New Age, to which Schiller also belonged, the Age of Enlightenment, a mocking and arrogant spirit, rejected this old-fashioned science. No physical connection between the movement of celestial bodies and terrestrial events has been revealed. Interest in astrology faded away, and was awakened only on the eve of the 20th century, when the fashion for theosophy, occultism, spiritualism spread. Astrology also came to court. She experiences a new surge in popularity in the 1960s. Horoscopes were the most successful then, as now. After all, among the tips and answers given out at random by them, there are no and there will be accurate ones. Scientists call it a coincidence, but professional astrologers are only proud of another success. Which of them is right? Let's make another extract, this time from Cerdan's book Expanding the Boundaries of the Universe. In one of his writings, Kepler warned researchers not to throw the child out with the bath water when they frivolously discarded the astrological superstition. To this day, the analysis of the predictive possibilities of astrology continues. So far, no child has been found in this bath, only muddy water. As you know, the famous astronomer Kepler compiled horoscopes, but here's how he expressed his attitude to classical astrology. The astrologer who predicts something exclusively from the sky and is not based on the character, soul, mind, strength and appearance of the person to whom he predicts, goes the wrong way and gives advice for good luck. How is it not clear whether astrology is a science? Geocentric system of the world. This system of the universe seemed to illustrate the famous phrase of Protagoras, man is the measure of all things. In the center of the world, the earth rested here or rotated around its axis, which means that man was in the center of the universe. The sun, moon and planets revolved around their mistress, the earth. This seemed to be an unshakable truth, because people from time immemorial have seen a lot of fixed stars in the night sky, and this suggested that the earth is also immovable. In this world, gripped by a blissful peace, only the sun, the moon, and the planets moved. With the development of mathematics, scientists could not help but believe that these movements could be described in order to then predict the position of celestial bodies. In its ideal embodiment, the ancient Greek scientist Evdoks knit sky, years of life 390, 338 BC, the movement of celestial bodies was reduced to the sum of uniform rotations of a number of spheres on whose surface there were planets. All spheres, they were called homocentric spheres, revolved around a common center, where the earth was. However, the apparent simplicity of this scheme was very deceptive. Ancient Greek astronomers have long noticed some oddities in the behavior of celestial bodies. The fact that the sun moves unevenly along the ecliptic, the fact that the moon draws a wavy line in the sky, the fact that the planets, moving among the stars, ride out incomprehensible loops. Striving for accuracy and harmony at the same time, Evdoks, in order to get a qualitatively correct picture of celestial movements, selected for each planet his own complex combination of several spheres. This is how, with the help of 3 spheres, he described the movement of the moon. The first sphere rotated around the central axis, making 1 revolution per day. The second one made a turn relative to the previous one in 18.6 years. Finally, the third sphere fixed on it made 1 revolution in 27 whole 3/10 of a day. At the equator of this sphere was the moon. The addition of a series of rotations occurring in different planes gave a result that coincided with the observation. Well, from the point of view of kinematics, it does not matter at all whether the Earth revolves around the Sun or the Sun around the Earth, the distance between them remains unchanged, wrote the Russian historian of science Sidomir. A contemporary of Eudoxus, Heraclitus of Pontus, years of life 390, 322 BC, based on the fact that Mercury and Venus never depart from the Sun further than an arc of a certain value, assumed that they revolve around the Sun. This idea became generally accepted in Hellenistic astronomy. However, the sun itself, like the moon and stars, revolve around the earth. Thus Heraclitus introduced the concept of epicyclic motion into astronomy. The celestial body performing it revolves around a certain center, which in turn revolves around the earth itself. One of the greatest philosophers of ancient Greece, Aristotle, years of life 384-322 BC, theoretically justified what seemed obvious and what Eudoxus claimed, that the earth is at the center of the world. In his book about the sky, he wrote that the earth must necessarily be in the center and be stationary, apparently because bodies thrown up with force fall back to the same place, even if the force throws them an infinitely long distance. From this it is clear that the earth does not move and is not outside the center of the universe. If there were no such center as the earth, the fall of objects would continue forever. The shape of the earth, Aristotle continued, must necessarily be spherical, because each of its parts has weight and tends downward until it reaches the center. Circles, epicycles and difference, later firmly connected with the name of Claudius Ptolemy. The Heptarch also suggested that the sun orbits the earth evenly and moves in a circle, but the earth is displaced relative to the center of this circle. This can explain the different duration of the seasons. After all, through observations, the Heptarch found that spring lasts about 94.5 days, summer, 92.5 days, autumn, 88 days and winter, about 90 days. The orbit along which the sun moved, he called the eccentric, and the distance between the two centers, the eccentricity. He selected its value so that it corresponded to the results of his measurements. It was more difficult with the planets. Their observed movements were too complex to be described using simple geometric models. The Heptarch failed to solve this problem. The ideal model of the universe by ancient standards was created only almost 300 years later. Its author was the last of the outstanding Greek scientists, Claudius Ptolemy. The years of life of the 100th, 160th AD. He replaced the simple scheme of the Heptarch. Each celestial body makes one circular motion around the center of the planetary system, with a more complex and precise scheme of several circular movements. It was she who made it possible to explain the looping movement of the planets. In addition, Ptolemy so skillfully modified the system of epicycles and difference that the movement of the planets could now be predicted for many years to come. And more from astronomy was not required then. In the simplest case, according to Ptolemy, the planet rotates along an epicycle, the center of which moves along another circle, the trim, skirting the stationary Earth. In order to fit the theory to the observations, additional epicycles had to be introduced. According to the Russian astronomer Bronstein, Ptolemy managed to find such dimensions and speeds of rotation of all the wheels of his universe that the description of planetary movements reached high accuracy. Ptolemy's system became the crown of ancient astronomy. It gave results that perfectly matched the observational data. It was possible to make new amendments to it, significantly complicating it, but at the same time achieving the highest accuracy of results. This, however, ruined her. For 1500 years, astronomers have been refining the Ptolemy system. By the beginning of the 16th century, 77 circles, difference and epicycles were already required to describe the movements of the Sun, Moon and the 5 planets known at that time. Many astronomers have come to consider this theory extremely complex. This opinion was shared by the Polish priest and astronomer Nicholas Copernicus. Years of life 1473–1543. He sought to make Ptolemy's model more slender and simple. According to Copernicus, he took the trouble to read the books of all the philosophers he could get, wanting to find out if anyone had ever expressed the opinion that there were movements in the world's spheres that were different from those assumed by teachers in mathematical schools. So he found the ancient thesis about the movement of the Earth. If we follow it, considering that the Earth is just one of those planets that, rotating around its axis, move along an epicycle, while the Sun is in the center of the universe, then the world system becomes much simpler. In this heliocentric system, the number of circles is reduced to 34. The Copernican system, described by him in his main book on the circulation of the celestial spheres, turned out to be convenient for calculations. It made it possible to explain the apparent movement of the sun across the firmament, although in its original form it was not fundamentally more accurate than Ptolemaic. However, the transition to the heliocentric system, where the Earth orbits the sun, so changed all ideas about the structure of the world that this was soon followed by the discoveries of Galileo, Kepler, Newton. Therefore, the Copernican doctrine was the foundation on which all modern science is built. In search of counter-Earth. For more than 2 decades since the first exoplanet was discovered, a planet lying outside the solar system, astronomers have been searching for a second Earth, where living conditions similar to those on Earth have developed. The anti-Earth or antichthon is also a double of the Earth, but it should not be looked for in distant star worlds, but very close. It supposedly orbited in the same orbit as the Earth, moving synchronously with it, and therefore was invariably covered by the solar disk. This is a hypothetical planet. For astronomers of the past it was the elbow that is close, but it cannot be reached. Located only 2 astronomical units away from us, at a distance of 1 diameter of the Earth's orbit, it remained inaccessible to observation from Earth. With the help of ground-based telescopes, it was easier to peer into the life of other galaxies than to notice this planet fooling us. That's the thing about ground-based telescopes. With the development of cosmonautics, there was no doubt that there was no enemy of the Earth. But it lasted a long time. It was first mentioned in the 5th century BC. Its description was left by the ancient Greek philosopher Philolaus. Years of life 470, 388 BC. Philolaus of Croton was an adherent of the mathematician Pythagoras, who created a school, a kind of sect that attributed real power to numbers. At the end of the 5th century, the Pythagorean mystics aroused the hatred of their fellow citizens. They were brutally dealt with. According to legend, one of the 2 survivors was Philae. Ancient authors write that Philolaus was the first of the Pythagoreans to publish their teachings. He wrote a book about nature that has come down to us only in fragments. It also talked about the structure of the universe. The Byzantine writer of the 5th century AD, John Stubbe, described this fantastic system of the world in this way. Philolaus places a fire in the middle in the center, which he calls the hearth of the universe, the house of Zeus, the mother of the gods. In addition, he receives another fire, located above everything and serving as an all-encompassing one. The first central fire by nature. 10 divine bodies are circling around him in a round dance. The sky and the planets, behind them the sun, under it the moon, under it the earth, under it the anti-earth, and after them all, fire. According to another version, the earth did not represent a single body, but consisted of 2 independent hemispheres, the earth and the opposite, the earth, separated along the equator by a gap through which the heat of the sacred flame penetrated the firmament. With such a system of the world, the counter-earth, rotating synchronously with the earth, remained invisible, since it is covered by the body of the earth. Modern researchers note that Philae's hypothesis would be easy to test by our standards by equipping an expedition that has passed at least a quarter of the arc of the globe. However, Zhitomirsky ironically said, for that era such advice would be tantamount to offering our astronomers to fly to the center of the galaxy and check if there is a black hole there. The expedition was also impossible because Philolaus, unlike other Greek astronomers, considered the Earth to be a flat disk. We live on the side of the Earth that is always turned away from the central fire and facing the Sun and other planets. Therefore, life is possible here. The terrible fire does not burn the world to the ground, and only its particles illuminate and warm the Ikumen, the inhabited part of the Earth. After all, the Sun is not visible, it reflects the fire that is in space. The reverse side of the Earth, facing the opposite Earth and the central fire, is uninhabitable. We do not know how reliably John Stobie expounded the mystical teaching that arose 1,000 years before him. For example, Aristotle in Meteorology, commenting on the astronomical theory of the Pythagoreans, explained the appearance of the opposite of the earth in this way. Since they defined numbers as the beginning of all nature, they summed up all the definitions and parts of heaven and all nature under the numbers and their ratio, and where something did not coincide, they tried to make up for this shortcoming so that a coincidence would turn out. Since, for example, the number 10 seemed to them the most perfect, embracing the whole nature of numbers, they said that there were also 10 spheres moving in the sky. But since we see only 9 such spheres, they invented the 10th, the counter-earth. As for the 9 spheres mentioned, these were the spheres of the fixed stars, the spheres of the 7 planets, Saturn, Jupiter, Mars, Venus, Mercury, the Sun and Moon, and the sphere of the Earth. But is it only for the sake of the harmony of numbers that the opposite Earth appears? In the Pythagorean cosmos, she has an important role to play. After all celestial bodies were then considered ethereal bodies, that is, light, having a very small mass. The Earth was a huge lump of firmament. It would not have been a problem if Philolaus, like other Greek scientists, had placed it in the center of the universe. But it revolved around the central fire. In this case, if the massive Earth was on the periphery of the universe, its center might not coincide with its center of gravity. The harmony of the celestial spheres would be disrupted. Philolaus, or one of the Pythagoreans whose teachings he recounted, balanced the Earth by placing a planet as massive as ours on the other side of the central fire. In the system of the world, according to Aristotle, there could not be such a problem. The Earth itself, which had an ideal ball shape, has now been motionless in the center of the universe for 1500 years. All the other planets, suns and stars surrounded the Earth. In this majestic picture of the cosmos, drawn above us, there could not be a single shelter for the enemy of the Earth. Since the middle of the 16th century, since the time of Nicholas Copernicus, the Earth has left the center of the universe, yielding it to the Sun for several centuries. In this updated system of the world, the antipode of the Earth suddenly found a place. French mathematician Joseph-Louis Lagrange, years of life 1736–1813, analyzing the movement of celestial bodies, discovered that a certain point lying behind the Sun is special. Today we know 5 so-called Lagrange points. Any celestial body that finds itself in one of them can stay there indefinitely, because the forces acting on it, including the forces of attraction of the Sun and the Earth, are balanced at these points. Only an external influence can force this object to leave the Lagrange point. Where are these points located? 2 lie in close proximity to the ground. One is between the Earth and the Sun, and the other is on the other side of the Earth. 2 more are located along the Earth's orbit ahead and behind the Earth, deviating from it by 60%. But the last of these points, it is officially called L3, is located where the opposite Earth should have been, on the other side of the Sun, in the orbit along which the Earth is moving. Theoretically, an unknown planet could be located there. Let's say the age of cosmonautics has not yet come. In practice, this is not possible for the following reason. Lagrange performed the calculation within the framework of the 3-body problem, ignoring the influence of all other planets except Earth. However, they also have some effect on the planet, which is located at point L3. Calculations show that in just a few million years, gravitational perturbations will rock the counter-Earth, and it will leave the Lagrange point and collide with the Earth. Today, scientists are sure that if the counter-Earth had appeared simultaneously with the Earth, then about 4.5 billion years ago, shortly after the formation of the solar system, both planets would have collided. The Earth was saved by the fact that the probability of the formation of 2 identical planets at the same distance from the Sun is very small. In search of the 7th-8th heaven, the world of medieval Europe appeared on the ruins of the Roman Empire. It is not surprising that his ideas about the cosmos were inherited from antiquity. They were based, first of all, on the writings of Plato. Especially important for medieval science was his Dialogue of Themes, which is the only systematic handwriting of Plato's cosmology. Written several centuries before the triumph of Christianity, it reads like an apology to God the Creator. He built the cosmos as a single whole, made up of integral parts, perfect and not involved in decrepitude and ailments. He rounded the cosmos by rotation to the state of a sphere, the surface of which is equally spaced from the center everywhere. That is, he gave the outlines to the universe, of all the outlines, the most perfect. In the 12th and 13th centuries, the writings of Aristotle and Ptolemy came to Western Europe from Byzantium and Arab countries. The happy acquisition of Aristotle's works was fateful for Europe, because they represented a complete rational system that explained the whole world in its entirety, based on natural causes, emphasizes the Australian historian of science Alistair Crombie in the book From Augustine to Galileo. Emancipation of natural sciences. Such an approach corresponded to the spirit of the times that prevailed in the High Middle Ages. The growing desire to rationalize all aspects of life, including faith. The most visionary was revealed what Christianity was originally looking for, but could not find. A philosophical system that could be harmoniously combined with the Christian doctrine, and which thereby promised to become a rational pillar of dogmatics and a weapon of apologetic. The Dutch historian of science Edward Dijkster Hayes wrote in the book Mechanization of the Worldview. The works of Aristotle and Ptolemy translated into Latin caused heated discussions, which were attended by the greatest scholars of the High Middle Ages, John Sacrobosco, Roger Bacon, Albert the Great, Thomas Aquinas, Robert Grosseteste. In these disputes, a rational idea of the surrounding world and the cosmos was formed. What was this cosmos like? The medieval cosmos was divided into a world under the lunar and celestial spheres that towered above it. The globe rested motionless in the center of the universe, surrounded by a system of concentric celestial spheres. On the last, the highest of all, inaccessible to the eyes of man, sat God. The celestial spheres, not subject to change, were perfection itself. The world under the moon, the world of the earth, was shaken by changes and metamorphoses. Everything here was shaky and unstable, intimidating with weaknesses and flaws. In the early Middle Ages, the system of the world is unambiguous. The spheres of the moon, sun, planets, Venus, Mercury, Mars, Jupiter and Saturn, as well as fixed stars, were alternately located above the earth. The planetary spheres glided perfectly one relative to the other. They were absolutely transparent, because they consisted of quintessence, or ether. Each planet was attached to its own sphere. It was generally accepted that the stars and planets were created from the same ether as the celestial spheres. We see them only because the density of ether in them is unusually high. Therefore, they reflect sunlight or glow themselves. All these heavenly bodies are different faces of eternity, they can never be destroyed. The only change to which they are subject is a uniform circular motion. It can last indefinitely. Medieval scholars usually added two more spheres to this ancient scheme, revealed in the revelations of the Holy Book, the Bible. Thus, in the first verses of the book of Genesis it says, "And God created the firmament, and separated the water that is under the firmament from the water that is above the firmament." It was believed that the focus of this water above the firmament was a crystal sphere. It was believed that it was the root cause of the movement of all the other spheres lying under it. Blessed souls of virtuous people and saints often settled there. Finally, outside of it was the empire, the kingdom of God and heavenly beings, angels, archangels, cherubim, seraphim. The great Portuguese poet Luís de Camões gave enthusiastic praise to Empyrean in his poem The Lusíades and the First Orbit, that in the radiance the rotation embraces smaller spheres, that with fiery fierce sparkle builds a limit to vision and mind, then empires, blissful sojourns, high souls are a divine destiny. They taste eternal happiness there. What kind of vanities in the world we don't know. However, just as if hundreds of people suddenly saw the same dream and, waking up, began to write down its fragmentary features, and then, after checking the sketches, they were convinced that they were all writing about different things, so medieval authors left us a very different description of the cosmos, revealed to them in reading ancient authors and in his thoughts and visions. So, the Anglo-Saxon chronicler Bede Venerable Years of Life 672-735 writes only about the 7 heavenly spheres, following the Bible, and not ancient models. Nevertheless, as noted by the French historian Jacques Legave, the Greek heritage manifests itself in the cosmology of trouble with full evidence, right down to terminology. Directly above the earth stretched the sphere of air, above it, the sphere of ether, then, the sphere that contained all the planets. Bede called it Olympus, because the planets are named after Greek gods. The heavenly fire was burning over these heavens nearest to us. Sometimes it reminded of itself, as it was believed in the Middle Ages, then with flashes of the aurora borealis, then with the ominous flight of a comet, then with a quick flash of meteors. Above this sphere stretched a vault of fixed stars. The heaven of angels rested above, and the seventh heaven, where the Holy Trinity dwelt, closed the world. The cosmology of Bede is interesting because it shows how an educated person who lived in the 8th century imagined the universe. The Christianization of this concept, continues Lviv, ended with its simplification, as evidenced in the 12th century by the lamp of Honorius Augustidunsky, who distinguished only 3 bodies: the corporeal sky that we see, the spiritual sky, where spiritual substances, that is, angels, dwell, and the intellectual sky, where the blessed contemplate the face of the Holy Trinity. Other authors, comprehending the heavens, avoided this rather reprehensible minimalism. British mathematician and astronomer John Sacrobosco Years of Life 1195-1256. The author of the treatise on the sphere, written about 1230th year, which remained the standard textbook of astronomy until the 17th century, preferred the order of spheres that Aristotle adhered to. Mercury and Venus are placed next to the Moon, only then the Sun and the rest of the planets follow. Almost all the images of the celestial spheres that appeared in the Renaissance and modern times correspond to this pattern. Thomas Aquinas, the years of his life 1225-1274 wrote, referring again to the ancient authority. Pythagoras says that there are 10 spheres moving in the sky, of which only 9 are visible on earth. They are comprehended through the movement of the 7 planets. The 8th is through the movement of unchanging stars, the 9th is due to the phenomenon of the day, this is the prime mover. Dante Alighieri, the year of his life 1265-1321, built his universe from 9 heavens. He combined the crystal sky and the sky of the prime mover into one whole, and he did not consider empires to be a special sky. If we now turn to how medieval scientists imagined, let's say in modern language, near-Earth space, what stretched between the Earth and the Moon, then we will find 4 more invisible spheres here. They consisted of 4 ancient elements: air, fire, earth and water. The elements were arranged according to the specific gravity. The earth was closest to the central part, it was surrounded by water, air stretched above it, and finally, up to the sphere of the Moon, heavenly fire was poured out. It should be clarified here that the sphere of the earth cannot be identified with the globe that it surrounded. This sphere simply consisted of an element called earth. Medieval theologians saw it as an illustration of the biblical verse about the firmament that rests between 2 waters. And God called the firmament heaven. At the end of the 16th century, the Italian philosopher and astronomer Giordano Bruno, the years of his life 1548-1600, was the first to speak publicly about the imperfection of the celestial spheres. Almost all astronomers before him, including Copernicus and Kepler, believed that the cosmos was limited to the sphere of fixed stars. Bruno also stated that the universe is infinite, and all the stars that we see are the same sun, only located very far from us. Their planets revolve around them. They are also inhabited by intelligent beings who, perhaps, are not at all like us. For a century and a half of Dobron, Cardinal Nicholas of Cusa indulged in no less daring fantasies. Years of life 1401, 1464. The closest advisor to Pope Pius II. He claimed that the universe has no boundaries, that it is infinite. The machine of the world has, so to speak, its center everywhere, and its circumference nowhere, because God is a circle and a center, since he is everywhere and nowhere. Now the celestial spheres, which Bruno had written down, had finally fallen, freeing countless stars from their imprisonment, which had scattered into the infinite distance. But in this universal catastrophe, the destroyer of medieval cosmology himself died. By that time, science and theological dogma had finally diverged. Bruno was waiting for Cardinals Nisan a bonfire. For his sacrilegious speeches, for his ruthless denunciation of myths, he was, according to the custom of the Inquisition, burned. The execution took place in the time of Cervantes and Shakespeare, Kepler and Galileo. The system of the world of Tycho Brahe. In the year 1588, the famous Danish astronomer Tycho Brahe, years of life 1546-1600, and the first printed a book entitled About Recent Phenomena in the Celestial World. Based on the results of his astronomical observations, he decided to combine the irreconcilable in it, the old rejected doctrine and the new one that rejected it. To unite the system of the world, which was considered infallible for 1500 years, and the system of the world, which has been rejected by church authorities and many learned men for half a century, and which was created from the spirit of contradiction of the first. So Tycho Brahe decided to take the best of Aristotle's physics, Ptolemy's geocentric system of the world and Copernicus' heliocentric system of the world, which moved the earth and made it revolve around the sun. This story began in November 1577 year, when a bright comet appeared in the sky. Since ancient times, the comet has been considered a messenger of disasters. From its diabolical glow that flashed over the world, people were waiting for an imminent war or plague. Her deceptive fire burned for 3 months. These months were happy for Brahe. He regularly observed the comet. Aristotle once argued that the lights of comets are nothing but an atmospheric phenomenon. Above the lunar world is inaccessible to them, it is eternal and unchangeable. This was believed even now. However, the results of observations by Brahe and other astronomers indicated that this comet was 3 times farther away than the moon. She moved as if piercing the firmament. Her path crossed those celestial spheres, along with which, as Aristotle believed, the planets move. So these spheres don't exist. Brahe took up writing a book about comets. But sometimes the book is like a ship that, having set sail, suddenly returns to take on board another very important passenger. Brahe's book, dedicated to recent phenomena seen in the sky, suddenly contained a new system of the world outlined by him. That's how he explained her necessary appearance. I believe that the old Ptolemaic arrangement of the celestial spheres was not elegant enough, and that the assumption of such a large number of epicycles, through which the apparent movements of the planets relative to the sun are explained, should be considered superfluous. At the same time, I believe that the recent innovation of the great Copernicus, who resembles Aristarchus of Samos with his ideas, very subtly eliminates those places that are superfluous and inconsistent with Ptolemy's system, and does this without violating mathematical principles. However, the Earth's body is large, slow, and unsuitable for movement. I, without any doubt, adhere to the opinion that the Earth that we inhabit occupies the center of the universe, which corresponds to the generally accepted opinions of ancient astronomers and natural philosophers, which is attested above by the Holy Scriptures and does not spin in annual circulation, as Copernicus wished. But how did he manage to unite irreconcilable ideas that are at war with each other as frenziedly as duelists? What did he sacrifice to reconcile his enemies? What a compromise seemed to him a new word in science. Brahe was not only a great astronomer, but also a brilliant designer and mechanic. He made most of the tools he used himself. To improve the accuracy of measurements, he increased the size of instruments, and also came up with new methods of observation, trying to minimize any errors. For example, for this he developed a special sight for the armillary sphere. As noted by Zoetemer, Bragi was the creator of the most accurate instruments before telescopic astronomy. But it was the certainty that his measurements were the most accurate that alarmed him. If, with the help of his instruments, he failed to observe the annual parallax of the stars, their apparent movement, and they remain motionless, although the Earth, as the great Copernicus claimed, moves and in a year must pass a distance twice as great as that which separates it from the Sun, then maybe Copernicus was he mistaken. Tycho Bragi wrote in 1589 to his assistant, the German astronomer Christoph Rothmann. Do you think it possible that the distance between the Sun and Saturn would not be even 1/700th of the distance from the sphere of fixed stars? And yet, it must be so by all means, if the annual path of the Earth, viewed from the fixed stars, should be only 1 minute of arc. But then the fixed stars of the third magnitude, whose apparent diameter is also equal to a minute, would have to have the dimensions of the Earth's orbit. He could not believe not that the size of the stars is so cyclopically large, not that they, so similar to planets, can be bodies of a completely different nature, much brighter. It is now that we understand that, looking at the firmament, we do not see the true size of the stars, but the brightness emanating from them. The apparent brightness, which we call the stellar magnitude. In Braga's time, astronomers thought otherwise. The Danish scientist was unlucky. He was the last great astronomer who lived before the invention of the telescope. In the 17th century, scientists became convinced that fixed stars do not have an apparent diameter at all, but appear to the armed eye as just luminous dots. The parallax of the stars closest to Earth was discovered only in the first half of the 19th century. Not only Tycho's instruments, but also the telescopes of the next 250 years were unsuitable for this task. Well aware of what he did not like about the Copernican system, Bragi proposed a system kinematically equivalent to the heliocentric, but free from this disadvantage. In the same book he wrote, "Since, I will say, I was thinking about the fact that both hypotheses, Ptolemy and Copernicus, admit a lot of absurdities, then I began to think in depth about whether it was possible to open a hypothesis with the help of any conclusions, which in any respect would not contradict both mathematics and physics, and would avoid theological condemnation, and at the same time would fully correspond to the heavenly phenomena." In the Tycho Bragi system, as in the ancient Greek scientist Heraclides of Pontus, the years of life, 388-315 BC, all other planets, except ours, revolved around the Sun, and the luminary itself, like the sphere of stars, revolved around the Earth. This model perfectly explained the features of the trajectory of the planets and even predicted the phases of Venus, discovered only with the invention of the telescope. From a purely computational point of view, it was no different from the Copernican system, but it had an important advantage: it was not condemned by the Inquisition. Brahe was proud of his system of the world, but it did not play a significant role in the history of astronomy, although it aroused the interest of contemporaries. There are two known cases when other astronomers tried to pass it off as their own discovery. Among its few supporters, one should single out the Italian astronomer Giovanni Battista Riccioli, years of life 1598-1671, author of the book New Almagest, which was a set of astronomical knowledge of that time. However, Riccioli modified the geo-heliocentric, as it was dubbed, system of the world of Tycho Bragi. He further limited the power of the Sun, forcing Jupiter and Saturn to orbit the Earth as well. However, this innovation did not help. The Braga system was rejected by most scientists back in the 17th century as unjustifiably and artificially complicated compared to the Copernican system. She finally won. On a leash of magnetic force. At the beginning of the 17th century, it turned out that a strict mathematical order prevails in the solar system. Each planet moves along an ellipse, which looks like an elongated circle and has two foci besides the center. The Sun is constantly located in one of them, so the planet is now approaching it, then moving away. At the same time, the speed of the planet also changes. Approaching the Sun, it accelerates its run, and moving away from it, it slows down. And the farther the orbit is from the Sun, the slower the planet moves along it. But what kept this order in heaven? In the classical celestial mechanics of Aristotle, the stellar sphere stretched over the earthly world had a first movement that did not descend along the lower celestial spheres to the planets closest to us, including the Moon. The creator of the new celestial mechanics was the German scientist Johannes Kepler. Years of life, 1571–1630, court mathematician of the Holy Roman Emperor Rudolf II. After the death of the Danish astronomer Tycho Brahe, Kepler received at his disposal a large archive of his astronomical observations. On the basis of Brahe's record, he deduced the law of planetary motion, the so-called law of squares, in 1601. For equal periods of time, the planet passes through equal areas of the orbit sectors. It is now known as Kepler's second law. The radius vector of the planet describes equal areas at equal intervals of time. In 1605, Kepler formulated another law. Each planet orbits in an ellipse, in one of the foci of which is the Sun. Subsequently, he received the first ordinal number among his laws. In 1609 in Heidelberg, Kepler published the book New Astronomy, where he outlined both of these laws. The theory of planetary motion was Kepler's greatest achievement. The full title of his famous book sounds like this: The New Astronomy, Causal or Physics of the Sky, described in studies on the movement of the star Mars according to the observations of the most noble husband Tycho Brahe. This lengthy name is not accidental. After all, Kepler set out not only to describe the visible, but also to understand the reasons for everything that happens in heaven. Unlike Aristotle, he believed that the movement of the planets is predetermined by the Sun. It was spinning and dragging other planets with it. To what force did they submit? Since school, we know that the planets revolve around the Sun under the influence of gravity. The honor of discovering this law belongs to Isaac Newton. A few decades before him, thinking about the movement of the planets, Johannes Kepler was also sure that some invisible force emanates from the Sun, to which all the planets obey. Maybe it's the same force that prompts the iron filings to obediently follow the magnet. In the 17th century, interest in the mysterious magnetic force is steadily increasing. In the 1600th year, the work of the English physicist William Hilbert on the magnet, magnetic bodies, and the large magnet, Earth, was published, in which he summarized all the accumulated results of observations and research over the previous centuries. Based on these facts, René Descartes, in his Principles of Philosophy of 1644, will assume that there is a special magnetic substance. Many of the phenomena we see stem from it. Descartes wrote this after Kepler had caused the greatest celestial phenomena taking place before our eyes, the movement of the planets in their orbits, with something similar to magnetism. It should be noted here that Kepler was a diligent reader of Hilbert's book, and the action of the magnet described there reminded him of the events taking place in heaven, gave him the key to understanding them. There is a kind of divine power, Kepler proclaimed from the pages of his book Harmony of the World, published in 1619. It's a kind of magnetic force, the soul of the engine. It emanates from the Sun like its rays and affects the souls of celestial bodies, prompting them to move in certain orbits. The Sun literally puts this force into the planets circling near it, just as, according to the then widespread theory of impetus, any engine, say a leg, a bowstring, a gun, transmits a ball, an arrow, a cannonball to an object subordinate to it, a driving force that now encourages this body to move on. This hypothesis was revolutionary also because at that time it seemed impossible that a force could act at such large cosmic distances. The intensity of this quasi-magnetic force acting on each planet is proportional to the distance from the Sun to this planet. And just as the intensity of light decreases as we move away from the source, the same thing happens with the soul of the mover. And the stronger the soul of the engine is with distance from the Sun, the more noticeably the amount of movement of any celestial body decreases. The idea of the soul mover appears in Kepler quite early, about the 1600th year. He uses his correspondence expressions the ability of the mover or the power of the mover. This clearly emphasizes that in the future, using the term the soul of the engine, Kepler still resolutely breaks with the Aristotelian concept. After all, even speaking of the soul of the engine, he actually means the power emanating from it. Even if Kepler was mistaken in believing that this force has a magnetic nature. He described what was happening in heaven according to all the rules of modern physics. Today, historians of science classify his soul mover among scientific myths, but this is a very plausible myth. Despite the fact that Kepler, in an effort to resubstantiate celestial mechanics, did not take into account either the influence of the mass of planets or the mutual influence of planets on each other, nevertheless, in general terms, the scheme of motion of celestial bodies drawn by him was correct. Kepler's laws derived from observations were subsequently used by Newton to justify the law of universal gravitation. Newton proved that under the influence of mutual attraction, two bodies, for example, the Sun and any planet of the solar system, will move, obeying Kepler's laws. The soul of the invisible engine, this soul of the engine, now only in a metaphorical sense, has become the force of gravity. One of the biggest discoveries made in physics in recent years, the discovery of gravitational waves in the 2015 year. In the autumn of the 2017, the Nobel Prize in Physics was awarded for it, again prompt us to recall Kepler's magnetic force. After all, gravity spreads, as we now know, like electromagnetic waves. The two theories of Kepler and Newton, rejected and generally accepted, truth and myth again converge with each other. In the erroneous, mythical, ideas are found, without which the truth is not complete. Was there a Phaeton planet? The existence of this legendary planet has been believed for a long time. This faith was helped by the highest power of science, mathematics. Perhaps, for the first time, Johannes Kepler spoke about this planet in 1596. He was very interested in the vast empty space between the orbits of Mars and Jupiter. It overshadowed the heavenly harmony. Kepler is looking for a law linking the time of the planet's revolutions. But then it turned out that with the existence of only 5 planets, it is impossible to find the law. Then he boldly admits 2 new planets. One between Jupiter and Mars, and the other between Venus and Mercury. The biographer of the scientist Przetycki wrote about the birth of this hypothesis. In the 1766th year, the German mathematician and astronomer Johann Daniel Titius formulated an empirical rule that made it possible to approximate the distance from the Sun to the planets known at that time. It turned out that these distances correspond to a simple numerical series. It is formed like this. Take the following numerical series, 0, 1, 2, 4, 8, 16, 32, multiply each of its terms by 0.3, and then add 0.4 to the results. There is such a numerical series, 0.4, 0.7, 1, 1.6, 2.8, 5.2 and 10. These numbers are exactly the distance from the Sun to the planets, including Saturn. You only need to measure the distance in astronomical units. 1 astronomical unit is equal to 150 million kilometers, that is, the average distance from the Earth to the Sun. Today, this law is called the Titius-Bode rule, because it became widely known after the work of the German astronomer Johann Elert Bode in 1772. This law corresponded in everything to the location of the planets of the solar system, except for one. At a distance of 2.8 astronomical units, 400 million kilometers from the Sun, no planet has yet been discovered. But this was required by the mathematical law. When, in 1781, the planet Uranus, following Saturn, was discovered, and it was exactly at the distance from the Sun that the Titius Bode rules predicted, astronomers conducted a systematic search for the supposed fifth planet. Success came to the Italian astronomer Giuseppe Piazzi on the night of January 1, 1801 year. He discovered a small planet called Ceres. The long-awaited opening took place, but it was soon overshadowed by new discoveries. Those fell down as if from a cornucopia. Pallas, Juno, and Vesta were discovered. It was then that the German astronomer Heinrich Wilhelm Olbers, years of life 1758, 1840, by the way, discovered Pallas and Vesta, suggested that all the discovered minor planets are fragments of one once disintegrated major planet. A contemporary of Hoffmann and Chamisso, he even indulged in romantic fantasies, saying that this planet, like Earth, was habitable and, perhaps, there was its own civilization. The lost planet was named Phaeton. It was reminiscent of an ancient Greek myth. It said that the sun god Helios swept across the sky every day on 4 fiery horses. One day his son Phaeton decided to ride his father's chariot, but the horses did not obey him and rushed to the ground. Then Zeus threw lightning at the chariot. Phaeton died, the fiery horses sped away, and the earth was saved. Some enthusiasts even believed that the planet Phaeton collapsed during the time of ancient Greece, and the well-known myth is a poetic account of the disaster that shocked Helen. In fact, there is an asteroid belt between Mars and Jupiter, and Ceres was only the first of them. The famous French astronomer Urbain Le Verrier, years of life 1811-1877, tried to determine the possible mass of the planet Phaeton. Of course, he, like other scientists, was sure that many asteroids had not yet been discovered. However, the knowledge of celestial mechanics still allowed us to estimate the total mass of all known yet unknown minor planets. To do this, Le Verrier decided to calculate how the asteroid belt affects the movement of Mars in orbit. Knowing the magnitude of the gravitational impact, it is possible to calculate the total mass of asteroids. According to Le Verrier, it did not exceed 0.1.0.25 of the mass of the Earth. Other astronomers, not trusting the conclusion of the venerable scientist, themselves tried to calculate the mass of Phaeton. She was still small. Today, astronomers are even more aggressive about the Le Verrier result. They believe that the mass of Phaeton is overestimated at least 10 times. If you make this vanished planet out of asteroids, it will be no bigger than the Moon. Recall that the mass of the Moon is 0.12 thousandths of the mass of the Earth. Probably, a planet simply could not have formed in this part of the solar system. After all, when the huge Jupiter was formed, it collected all the matter, all the planets of winter, the embryos of future planets that turned out to be relatively close to its orbit, where Phaeton was supposed to appear. Meanwhile, astronomers of the past centuries even managed to study the Phaeton. Contrary to calculations, it was supposedly larger than Mars, but smaller than Jupiter. It was located on the border of the habitable zone of our solar system, between cosmic life and death. There, as Olbers believed, life could still arise, and it did, but a lifeless space stretched further from the Sun. Scientists have been making a lot of guesses, trying to understand what kind of catastrophe befell this ill-fated celestial body. So, the American researcher Charles Koval suggested that 175 million years ago, Phaeton collided with an asteroid and crumbled into millions of fragments. They, like bombs, rained down on neighboring celestial bodies for a long time. For example, on Mars there is a crater with a diameter of 600 kilometers and a depth of 25 kilometers. Why not see a shattered Phaeton behind this phenomenon? In addition, many of its fragments fell into the gravitational field of Mars, Jupiter, Saturn and Neptune, became their moons or replenished the planetary rings. In this hypothesis, which has become a legend, the fate of the 2 largest fragments was especially curious. For thousands of years, these sparkling fireballs have been orbiting the Sun. Later, one of these comets allegedly turned into the 9th planet, Pluto. The other, as in the hypothesis of the American researcher Immanuel Golikovsky, became the morning star Venus. At one time, the orbit of this comet repeatedly intersected with the orbit of the Earth, plunging people into horror. The danger was really real, wrote Velikovsky, whom none of the serious scientists believed. The Earth kept straying from its orbit. This led to apocalyptic events: earthquake, volcanic eruption, flood, fire. Climate disasters have happened more than once. The alternation of the seasons was disrupted. It was only around the 800th year BC that the space bombardment stopped. The last shells scratched our land. The forces of gravity calmed down. Since then, a comet with a fiery tail, that is, the planet Venus, has been peacefully circling in its orbit. However, the legend has dissipated over time. The hypothesis could not stand the test of practice. Later calculations showed that the planet Phaeton never existed. Only tiny planets orbited between Mars and Jupiter. Since 1983, an asteroid has been named Phaeton. However, it is not included in the asteroid belt, it is located much closer to Earth. Venus is being abandoned by satellites. The cloud curtain has long prevented the study of the surface of Venus through a telescope. There were no noticeable landmarks, red spots, dark seas there. Scientists could not even accurately determine the rotation period of this planet. At one time they believed that Venus is always turned to the Sun by the same side. It was only in 1961 with the help of radar observations that it was possible to establish that Venus still rotates, but very slowly. You won't get sad here. The day flew by and didn't notice. A day on Venus lasts 243 times longer than on Earth. If people could settle here, then any newspaper would publish an overview of the events that happened during the year. After all, it is shorter on Venus than a day. It lasts 225 Earth days. This beauty is frisky, voluminous, manages to offend the Sun faster than to turn around on its axis. Everything is mixed up here. Why does Venus rotate so slowly? Perhaps there was once a huge satellite next to her. He slowed her down. The powerful tidal forces generated by it have warmed up the planet. It didn't last long. Several 100 million years have passed and this satellite, becoming the size of Mercury, has left Venus. But since then, our celestial neighbor has remained a red-hot clumsy planet. Of course, this is only a hypothesis, but it has not yet been possible to refute it. In 2000, the radical hypothesis was published by Alex Alamy and David Stevenson from the California Institute of Technology. According to her, Venus in the distant past collided with another celestial body. It disintegrated and a satellite of Venus was formed from the debris. It looks like the theory of the origin of the Earth's moon. However, after another collision with a large celestial body, Venus began to rotate in the opposite direction. And then her satellite began not to move away from the planet, like the moon from the Earth, but gradually to approach Venus, until he collapsed on top of her. However, it is difficult to confirm this hypothesis, because the violent volcanic activity transformed the surface of Venus and erased all traces of ancient catastrophes. In general, the satellite of Venus was already discovered. It was noticed in 1672 by the Italian astronomer Giovanni Domenico Cassini. Years of life 1625–1712. By that time, the first director of the Paris Observatory. At first, Cassini doubted his discovery and did not publish reports about it. However, after 14 years, he discovered this object again and then left an entry about it in the observation log. According to Cassini, the satellite turned out to be large. Its mass was only 4 times less than the mass of Venus. Later, the same satellite was spotted by other scientists. In the year 1740, he was seen by the English astronomer and optician James Short, in the year 1759 by the German astronomer Andreas Mayer, and in the year 1761 by Joseph Louis Lagrange. In particular, the latter reported that the plane of the orbit of the satellite of Venus is perpendicular to the ecliptic. That year, 1761, was special. After all, from time to time the Sun, Venus, and the Earth are on the same straight line. At this moment, if you look at the Sun through binoculars or a telescope, you can see how a black speck of Venus is moving along its disk. The passage of Venus across the disk of the Sun is the name of this phenomenon. It is observed very rarely, once every 100 years. Then it repeats after 8 years, and again it has to wait a whole century. During this event, for 2.5 centuries, the attention of all astronomers has been focused on Venus. Fate has rewarded them with discoveries more than once. So, on the 26th of May, according to the new style, on the 6th of June, 1761st year, the Russian scientist Mikhail Vasilyevich Lomonosov discovered the atmosphere of Venus. That year, 5 astronomers observed the moon of Venus 18 times at once. Most interesting of all was the report of the German astronomer Abram Schouten. He saw on the 6th of June how Venus passes through the disk of the Sun and is accompanied by a small dark speck. However, on the same day, British astronomer Samuel Dan failed to see this satellite next to Venus. In 1764, 2 observers spotted the satellite 8 times. Others have tried to do this, but without success. Disputes were heating up. Someone stubbornly did not see the satellite, for others it flashed in the sky with enviable regularity. In 1766, Pater Maximilian Hell, director of the Vienna Observatory, suggested that all cases of observation of this self-willed satellite are explained by optical deception. The image of Venus looks so bright, he thought, that, reflected from the fundus, it reappears in the lens of the telescope. That's why enthusiasts see a speck near Venus. While some laughed at the curious stupidity of colleagues, others did not waste time in vain. In the 1777th year, the German astronomer Johann Heinrich Lambert, years of life 1728–1777, considered one of the founders of photometry. He led the basic concepts of this science, such as light intensity, brightness, illumination, albedo, and also established a number of photometric patterns. Published in the Berlin Astronomical Yearbook the most detailed information about the satellite of Venus. On average, it is 66.5 of the radius of Venus from the planet, that is, it is at the same distance from it as the Moon is from the Earth. However, this figure does not agree well with the orbital period of the satellite calculated by Lambert. 11 days and 3 hours. The uncertain situation with the satellite of Venus continued until the end of the 19th century. Trying to solve this mystery, the Belgian astronomer Jean-Charles Ozot put forward an unexpected idea in 1884. He found a pattern in the previous observation results. On average, the satellite was spotted every 1080 days, 2 whole 9600ths of a year. Maybe we are not dealing with a satellite, but with an independent planet? Orbiting the Sun, it approaches Venus once every 3 years. This phenomenon is called conjunction. Azo gave the name to this planet. He named her Neith, after the Egyptian goddess of hunting and war, whom mortals are not allowed to see. However, 3 years later, the Belgian Academy of Sciences published a lengthy report investigating cases of Neith sightings. It turned out that all these were stars accidentally spotted near Venus. For example, James Short actually saw a star whose magnitude was less than 1/8. The observations of Urbain Livret and Jacques Montaigne were explained in a similar way. The astronomer from Copenhagen, Christian Horibau, probably saw the star Theta from the constellation Libra in 1768. The Danish astronomer Redker especially distinguished himself. He alternately took 2 stars from the constellation of Orion and one of the constellations of Taurus and Gemini for the satellite of Venus. Alas, all of Lambert's orbital calculations were not worth the paper they were written on. After this revealing document was made public, only one case of observation of a satellite of Venus is known. On August 13, 1892, the American astronomer Edward Emerson Barnard, years of life 1857–1923, who had previously discovered the Horsehead Nebula, noticed an object near Venus with a stellar magnitude equal to 1/7. Not a single star should have appeared in this place. Everyone knew that Barnard's eyesight was excellent. Even today we don't know what he actually observed. Maybe an asteroid that flew past Venus, or a supernova that briefly flared up somewhere behind Venus. In this case, in a strange way, none of the other astronomers noticed this flash. And no one else has seen Nate. But astronomers now know that Venus has a pseudo-satellite. This is an asteroid 2002 VN68. Turning around the Sun and sometimes crossing the orbits of Mercury and Earth, it exactly echoes the movement of Venus, because their orbital resonance is 1:1. The second moon. In the 19th and 20th centuries, astronomers several times discovered a new satellite of our planet, the second moon. But each time the discoveries were not confirmed. This story began in 1846, when the director of the observatory in Toulouse, Frederick V, announced that his employees Lieben and Dossier had discovered another extremely small satellite of the Earth in the early evening of March 21, 1846. After checking their observation, he calculated that the second moon orbits in an elliptical orbit, making one revolution in 2 hours, 44 minutes, 59 seconds, moving away from the Earth at an apogee of 3,570 kilometers, and almost colliding with it in the peregrine, being only 11.4 kilometers from its surface. Subsequently, fascinated by the idea of a second moon, he even suggested that some features of the movement of the main satellite of the Earth are explained by the influence of this tiny planet. However, fellow astronomers ignored his discovery. Perhaps it would have been forgotten if the writer Jules Verne, unpopular in the middle of the 19th century. He happened to read about the discovery of the second moon, and this decisively influenced the fate of his heroes. In the novel Around the Moon 1869, a projectile, that is, a spaceship launched to the moon, became its satellite. The situation of the heroes seemed hopeless, but they were lucky enough to meet a small celestial body on their way, the very second moon. Is this really possible? Michel Ardan exclaimed. The Earth has 2 satellites. Yes, my friend, she has 2 companions, although it is considered that she has only one. After all, this second satellite is so small and its speed is so high that the inhabitants of the Earth cannot notice it. Only by observing the interference produced by him, the French astronomer, Monsieur Five, was able to detect the existence of this satellite and calculate its orbit. Do all astronomers recognize the existence of this satellite? Nicole asked. No, answered the barbecue. But if they, like us, had met him up here, they would not have been able to doubt anymore. The meeting almost led them to a collision with the second moon. This did not happen, but the projectile changed direction and eventually returned to the ground. Millions of people have read a popular science fiction novel, remembering both this important scene and the discovery allegedly made by a French astronomer. The successors of his case were found. In 1898, George Waltemath from Hamburg reported that he had discovered a whole system of tiny satellites of the Earth. He specified the exact parameters of one of them. The diameter of the second moon was about 700 kilometers. It was located at a distance of 1 million kilometers from the Earth, making one revolution around it for 119 days. According to Waltemath, sometimes this satellite is mistaken for the Sun. He referred to the American polar explorer Adolph Greely, who in October 1881, while in Greenland, allegedly observed the solar disk for 10 days after the polar night came. Waltemath also predicted that on the 2nd, 3rd or 4th of February, 1898, the passage of the second moon across the disk of the Sun will be observed. They were interested in his forecast. On the 4th of February, the post office in the German Greifswald turned into an observatory. A good dozen spectators, crouching at the windows of the office, peered into the sun, which dazzlingly sparkled above them. All of them, the director of the post office, Mr. Siegel, his household and colleagues tried their best to help astronomers. The sunlight cut into their unprotected eyes, but they saw clearly. They clearly saw some kind of dark spot that slowly, for an hour, rolled across the solar disk, which was 5 times wider than it. Has the discovery been confirmed? It soon became known that it was at this hour that two experienced astronomers, Winkler from Jena and Baron Iva von Benko from Pola, Austria-Hungary, were also observing the sun, but found nothing remarkable except ordinary sunspots. So the discovery turned into a mistake. Voltamat, however, did not calm down. More than once he predicted ere the second moon could be found. However, she again eluded observation. In 1903, American astronomer William Henry Pickering unwittingly ordered the search for this planet by publishing an article in a magazine about the photographic search for a moon satellite. After all, everything that was said about this hypothetical object could be applied to observations of the second moon. So, the article said that a satellite with a diameter of 30 centimeters, located at a distance of 320 kilometers from the Earth's surface, can be seen with a 3-inch telescope. A satellite with a diameter of 3 meters would be visible even to the naked eye. If it is not visible, then the diameter of the satellite is less than 3 meters. By the way, it would be appropriate here to return to the idea of 5, who believed that the second moon affects the movement of our main satellite. This could only be the case if the second moon was several kilometers across, but then it would certainly have been noticed back in Babylonia. In 1922, Pickering's article appeared in the same magazine, dedicated specifically to the second moon, this meteoric satellite. It caused a stir among enthusiasts, because it said, a 3 to 5-inch telescope with a low eyepiece is most suitable for searching for a satellite. This is the occupation of amateur astronomers. Just a few years later, the German astronomical magazine Der Stern reported that a German amateur astronomer, Spill, discovered such a satellite on the 24th of May, 1926 year when it passed through the disk of the moon. But this discovery, like others like it, had no continuation. The search for the second moon has even made astronomy akin to astrology again. In 1918, the English astrologer Cephariel Walter Richard Walt gave this celestial body the name Lilith. Walt believed that it was black in color, and therefore it could not be observed using astronomical instruments. Only in those minutes when this black moon passes through the disk of the sun, it can be noticed. Equally authoritatively, the astrologer said that Lilith's mass is not inferior to the moon, without thinking that such a huge body should influence the movement of the Earth. Let's leave astrologers aside and note that perhaps Piatti, Spill, Voltamat and their other colleagues were not at all wrong, they just discovered short-lived satellites of the Earth every time. After all, sometimes our planet captures small bodies flying past it, meteoroids. They do not orbit the Earth for a long time, for 100 to 150 hours, entering the upper atmosphere and gradually losing speed. After making a couple of turns and maybe surprising amateur astronomers, they usually disintegrate, forcing researchers who took them for a real satellite of the Earth to get lost in guesses. Some scientists also believe that the moon sometimes captures a small block approaching it. Calculations show that in a few years such a satellite will inevitably fall on the surface of the moon, perhaps having time to surprise fans of watching the starry sky again. The seekers of the second moon have not been transferred to our days. Another success awaited them in 1997, when Canadian astronomer Paul Vigert drew attention to a small asteroid 3753 Ruefen, which was moving in a very strange orbit. It looks like he was a satellite of the Earth. However, observations have shown that this is not such a faithful satellite of ours. It does not revolve around the Earth, and therefore it is a temporary companion for us. Similar pseudo-satellites, for example, 2002 AA-29, 2003 YN-107, 2010 with O16, were met by the astronomer later.